Hello, Andariki, hello, Annaru, all of you. Hello. Am I visible? How's the Josh, Sarji? How's the energy level? All of you are there, kada? So, very good afternoon, Andariki. Or very good evening, I should say. Yes. Good evening. Good evening, Nandini. Good evening, Spandana. So all of you are there, kada? Everything visible, right? Audio, video, everything is synchronized, kada? Any problem in it? Good, Harita. Very good evening. Chalo. Good evening, Parimala, Spandana. Keralachari, Shalini, Isha, very good evening, Isha. Hi, Sai Kumar. Hi, Raju. Good evening. Sanatana Saradi, very good evening. Sai Divya. Geeta Sri, very good evening. Andariki, very good evening. All of you. Chalo. So I wish all of you are very good. I hope everything is good and fine. And in class lo, we will start with the electrostatics chapter. Okay. Students, the chapter is going to be from very basics. Very basics to start chesi. We will be trying to take it to the, NEET level or something. So, how is the Josh? How is the energy, Andariki? Very good, Spandana. Very good. Yes. Very good evening, Pulisai Krishna. Very good evening. Yes, I will try to keep it one shot, okay. We will try to cover the full chapter in one go. But let's see what happens because, depends on various conditions also. Chalo, so let's start everything. Let's start about the electrostatics. What is electrostatics, Sarji? What are you typing, Andari? So I want you to interact with all of you, okay? Okay. Chalo. Yes. So electrostatics ante we will have to see the behavior of charged atoms or the forces. Okay, so basically we have to see in this chapter the behavior of charged particles ante. Okay, so sir, charged particles enti sir ji? So I can say, sir, that in each and every substance or in each and every atom or in each and every matter, number of positive charge is equals to number of negative charge kada. So total positive charge is equals to total negative charge. Can I say that? All of you andariki cheppandi. So for a matter, total positive charge is equals to, for a neutral matter kada. Okay, for a neutral matter, total positive charge is equals to total negative charge kada. So it is total negative charge ante. So Sarji, what is charge, sir? What is charge? Charge ante entira. I can simply say, sir, in each and every atom there are protons and electrons kada. So you do one thing, you try to make an imbalance between protons and electrons. So ante, for example, let's say there are 10 protons and there are 10 electrons. You remove one electron. There will be 9 electrons and 10 protons kada. So oka electron ni tisi, you get an extra positive charge. Are you understanding? So charge enti ante is simply the imbalance of the protons and electrons. Arey, video is blur kada. Why the video is blur? Okay, I'll try to fix it. Okay, I'll try to fix it. Let's see. Let us see. Clear now? Clear? Is it clear? Andariki okkasari cheppandi, is it clear? Video is clear or blur? Still blur? Is it clear andariki? Video is clear? All of you cheppandi. Okay, good. So now it's okay. Fine. So Sarji, the charge ante it's a imbalance of positive or protons or electrons. Good. It's clear now. It's clear. All of you. Amazing. Chalo. So Sarji, what did I say? I said that a charge is basically, cheppandi andariki, charge is imbalance of protons and electrons in an atom. Kada? Ante. Now, Sarji, it is not class 9 or class 8 session kada. It's not a session for your 7th or 8th class. Okasari cheppandi ra, video is clear or not clear? I hope it is clear kada. So as I am moving back, it is clear, right? Yes, it is clear. I hope so it's clear, okay? It's clear and visible. Andariki okasari cheppandi. Arey setup problem ra. I hope it's clear now. Visible, all of you? Is it visible? Andariki cheppandi okkasari. Yes. So I hope it's visible kada. Chalo. So Sarji, now we will be discussing something about the quantization of electrons or quantization of charge ra. Yes, Parimala, weightage for this chapter, at least 5 questions. At least 4 or 5 questions, you can expect it. Last time it was 5 kada. So you can expect at least 4 or 5 questions this time. Easily. Very easily, no problem. I don't know what's the problem. I think Chalo. So let's talk about charge. Statement చూడండి అందరికి. Charge is quantized. Sir, what do you mean by charge is quantized, sir? ఎప్పుడైనా you are taking a charge, the charge must be, that is, it must be an integral multiple of E. Arey, what is E re? E is the charge of electron kada. What is E? What is the value of E? So E is equals to, you remember andariki, 1.6 into 10 to the power minus 19 coulomb ra. Ante kada. You just remember E value is 1.6 into 10 to the power minus 19 coulomb. Andariki. Am I visible? Arey, what is happening re? Arey, I can't see the energy re. Can't see the energy re. Cheppandi. Yes, charge is a scalar quantity. You can say that. Point number 1. Point number 2, the value is this. So, Sarji, charge is always quantized. So, that means you can always get the charge Q is equals to N into E. What is N, sir? So, E case lo N is equals to 1 or 2 or 3 or 4 or ade. So, it must be a whole number. If it is present, it must be a whole number. It is absent, it should be 0. Ante. It can never be. Charge can never be 1.5 into E. Ardhamaindi? It can never be 2.3 into E. It is not there. It is not there. Not possible. Charge must be integral multiple of E. Ante kada. So, sir, there is a topic known as quarks. Quarks. What is quark, sir? Quark is a part of the charge, sir. Ji. So, charge is always either E or 2E or 3E. So, if I am asking you, sir, is it possible that charge is E by 2? Is it possible for a charge to have a value of E by 2, ra? E by 2 is possible or impossible, right? It is impossible, sir. Good. Endukante are cheppandira why it is impossible. E by 2 ante 0.5 E kada. It's not a quantized number. It's not a whole number. It is a fraction of the charge. It is not possible. But sir, what we observe is, we talk about quarks. So sir ji, quarks gurinchi matladalante, quark has two types. The first type is the up quarks and the second type is the down quarks. Sir, what is up quark and what is down quark, sir? So, I can't see your chats, Ray. Ray. Okay. So, sir, up quark has the charge of plus 2E by 3. And sir, the down quark is having a charge of minus E by 3. But you said that, sir, it is not possible for anything to have a charge in this fraction, kada? Then how is it taking E by 3? And how is it taking 2E by 3? It is not a charge, Ray. It breaks into, the charge has been broken into quarks, Ray. You always remember, quark is not considered into our standard charge definition. I hope you are understanding what I am telling to you. Chudandi andariki. Let's set the things, Ray. I'm feeling some heat, you know. Chalo. So this question has been asked in AIMS 2017. Mind lo pettandi. Proton and neutron are made up of quarks. What I'm telling to you, Ray? What I'm telling to you, Ray, when they bombarded the nucleus broke down. The nucleus broke into quarks, proton and neutron. What did I write, Ray? I wrote that up quark has a charge of plus 2E by 3 and down has a charge of minus E by 3 kada. So, meeru subatomic particle nu choose, there will be two up quarks. So, there are two up quarks and one down quark in proton ray. One down quark in proton ray. So, total charge gurinchi cheppandi andariki. Two up quarks ante plus 2E by 3. Plus 2E by 3. And talk about down quark ray, it is minus E by 3 kada. Cheppandi, what is total charge? 2E by 3, 2E by 3, 4E by 3. 4E by 3 minus E by 3 ante, it is 3E by 3. So, that is equals to E again. Chudandi. Ekkada vachi, in neutron, you have two down quarks ray. So, you have two down quarks and you have one up quark. So, charge gurinchi maatladte cheppandi, what is the net charge of neutron? 0 kada. So, down quark ki charge ante minus E by 3. Ekkada kuda minus E by 3. It should be plus 2E by 3 kada. So, minus E by 3, minus E by 3, minus 2E by 3, plus 2E by 3, and that cancels out. The net charge is 0. You remember in your mind that a proton has two up quarks and one down quark, while a neutron has two down quarks and one up quark. You also verify the charges. The charges are coming to be 0 and plus E over here. So, whenever you are talking about charges, we talk about charge on an object and it can never be 1.5 E, 2.5. It must be integral multiple of E. Ardhamaindi andariki. Arey, what are you telling in the chat? Chalo. Next. Sarji, let's talk about one question. Option A, option B, Coulombs, option C, option C, it is 3.2 into 10 to the power, not 3.2, I think we should take a different value. చెప్పండి అందరికి A, B, C, D. A for apple, B for ball, C for cat, D for dog. A for apple, B for ball, C for cat, D for dog. So, Sarji, the quantization of charge, what it says is B, D. You remove this knot, okay? You take which of the following charge is possible? Is possible, okay? చెప్పండి అందరికి చెప్పండి. D. Okay, let's see. The quantization of charge says, the inner charge you are taking, it must be n into E kada. The value of E is 1.6 into 10 to the power minus 19. So, Sarji, from here, ikkad nunchi I am writing n is equals to Q upon E kada. And this n must be, cheppandi, this n must be an integer. Ante. This n must be an integer. Now do trial and error and substitute. Petkondi. When I put the value for A, cheppandi, what is the value of Q? Q is 6.4 into 10 to the power minus 20 divided by 1.6 into 10 to the power minus 19 kada. E value, the value of E. So 1.6 ones are 1.6, it is 4, and this is minus 19 goes up, so it comes out to be 4 into 10 to the power minus 1. Chooskondi. It is 0.4 kada. Integer, is it integer? No, not integer, sir, not integer. Gone, gone. B గురించి చూద్దాం రే, చెప్పండి B గురించి. For B, n is equals to Q by E kada. Cheppandi, the value of Q is 3.1 into 10 to the power minus 19 divided by 1.6 into 10 to the power minus 19. This gone. Now it is 3.1 divided by 1.6. Are not divisible, ray. If it is not divisible, how can it be integer, ray? It is not integer, so it is gone, ray. Are gone. This also gone, ray. C also gone. Let's talk about C, B now. Ray, it was for C, ray. It was for C, ray. It was for C. Now let's see about B, ray. Let's see about B. B. Cheppandi. So n is equals to Q by E kada. Cheppandi, the value of Q is 4.8 into 10 to the power minus 18 divided by 1.6 into 10 to the power minus 19. So, Sarji, 1.63s are 4.8 and this minus 19 becomes plus 19. So, plus 19 minus 18 ante 1. So, 3 into 10 ante 30. This is a natural number. So, sir, B is my answer. Ante. It is also not divisible. Endukante it will become minus 2, 10 to the power minus 2. So, it will give me n value is equals to 0.04. And it is also not integer. Ardhamaindi andariki. Next. Very good, Harita, very good. C not there, Nandini. B. Raju, very good, Raju, very good. It's B. It should be B, right? It should be B. చెప్పండి ఇప్పుడు విల్ టాక్ అబౌట్ మెథడ్స్ ఆఫ్ ఛార్జింగ్ రా అందరికీ చెప్పండి. రెండు ఉన్నాయి కదా. ద ఫస్ట్ వన్ ఈజ్ ఛార్జింగ్ బై ఫ్రిక్షన్ రా. And the second one is charging by induction. Sir, charging by friction enti sir. Let's imagine I have a glass rod and I have a silk cloth. You rub it, simply you rub it. As soon as you rub it, some charges exchange and there comes a charge for this. Ante kada. For example, you can rub the silk cloth on a glass rod. Arey, we used to do an experiment kada. So there was used to be a pen and you used to rub it on your hair kada, and you paper small paper ni pieces you used to stick that kada. Very good. Charge exchange. Charge exchange ra. You can also say here the charge exchange takes place. So that means, sir, one body gets positively charged and the other body gets negatively charged. Ante kada? Good. Hi, Darkan. Good evening. Very good evening, Darkan. Now, sir, charging by induction. Idi na favorite procedure ra. Induction ni charge cheyali. So how do you charge ante, sir? Let's say I have a neutral object. Neutral metal. Metal kuda teeskochu, or you can take, if you want, you can dielectric also take it, okay? So metal or dielectric. Ekkada if you talk about the charging, it is valid for insulators and dielectrics. What is dielectric, sir? What is dielectric? We'll tell you, don't worry. Don't worry, I'll tell you dielectrics. So this is for metal or dielectric, conductor or dielectrics. So what you do is, it's a neutral object, you bring a positively charged object. So let's say this is a positively charged object. So ante, this is Rajnikant re. This is Rajnikant. So Rajnikant came into the colony. What happens re? What happens? Oh sir, all the women will come on the terrace to see him, kada? Yes sir, yes sir, yes, this is Rajnikant, so all the women negative charge will come close to him, you know, and all the positive charge, all the positive charge, it shifts to the other side. Now what we do is, you just try to imagine, okay, if it is a metal conductor, then the charge Q you bring close, same amount of charge minus Q comes over here. If it is a metal conductor. Endukante sir, metal lo there are huge number of free electrons. So if you take out a plus Q charge, automatically minus Q charge comes close to it. Endukante it's a Rajnikant re. It came into the colony, all the people are running to see him. Ande kada? Good. Now we do one smart thing. What do we do? We simply take a wire. We join the wire with this positively charged part, the other side of this conductor, and you slowly connect this wire with the ground. Ante. So what happens, Sergi, ante? All this extra positive charge, it flows through the wire to the ground. What did you do, sir? You did a very big fraud, Sergi. You gave a connection and you take out the switch. Sir, you gave us a positive charge, so we thought this negative charge will come here. And how can you do this, Sergi? This is known as connection deke meter katna, sir. What did you do, sir? All the positive charges gone, gone. So only negative charges left. So this is how you charge the object. One is by rubbing, charge exchange. The other is by friction, kada? Good. So that చలో. సో సర్జీ అంతే కదా. గుడ్. పాజిటివ్ చార్జ్ గాట్ న్యూట్రలైజ్డ్ రే. సో ఇప్పుడు లెట్స్ టాక్ అబౌట్ ద ప్రాపర్టీస్ ఆఫ్ చార్జ్ రా. వాట్ ఆర్ ద ప్రాపర్టీస్ ఆఫ్ చార్జ్ చెప్పండి అందరికి. అరే రే 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 సర్జీ 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 ప్రాపర్టీస్ ఆఫ్ చార్జ్. వాట్ ఆర్ ద ప్రాపర్టీస్ రే? Number 1, always quantized kada. Always quantized ante enti ra? Q is equals to n into E. N is a natural, not natural number, integer. N is an integer. Integer or natural, whole number. Array, whatever you want to take, you can take it, okay? N is a whole number, ante. So, sir ji, this is the first property of the charge. Sir, what is the second property ante? In an isolated system, the charge remains constant. Ate. What does it mean, sir? In isolated system, charge remains constant. For example, array చూసుకోండి రా అందరికి. I'm telling you the example. చూసుకోండి అందరికి. So let's imagine I have a box. Isolated kada, so that means no charge can come in, no charge can go out. Isolated charge. Ade. So let's imagine na daggara oka charges undi. So let's say this is charge Q1, this is charge Q2 kada. Let's give the values. Let's go with the values. Values. So let's say this is 10 coulomb charge and this is 2 coulomb charge ra. Ante kada. So what happened is, sir, we shake this box. We shake it completely. So friction happened, charge exchange happened. After that, when we are seeing it, shake chesi chusi tarvata, you say the first ball had a charge of 20 coulomb. Cheppandi charge on the other ball. What is the charge on the other ball, re? Arre, what is the charge on the other ball, re? How much charge is left on the other ball? Cheppandi, andariki cheppandi. Not zero re baba, not zero. Chuskondi, what is the total charge re? 12 coulomb kada. So Q net is equals to 12 coulomb. In the final scenario also, Q net must be 12 coulomb. Ante. So 12 nunchi 20 has came. How much left re? How much left? Minus 8 coulomb kada. Ante. Are you understanding? Good. Next property ra, third property చూసుకోండి. అరే అందరికి రే అబ్జర్వ్. Next property, charge can never exist without mass. So you can say, someone said in the chat box, very good. Always associated with mass. Raju, very good. Charge is always associated with mass. Are you understand this way? Charge ante your soul, okay? Soul. Atma kada, your soul. Charge is the soul and mass is the body. Are you understanding? Charge is a soul, mass is a body. In physics, we don't talk about Dayam and all, okay? In physics, we don't talk about supernatural things happening. You see, have you ever seen a soul, Ray? Have you ever seen a soul? You never seen a soul. But have you ever seen a body, dead body? Yes. So, Sarji, charge can never exist without mass. Soul can never exist without a body. But body can be there without a soul. Understanding? Ardhamaindi andariki. Same process. You see, soul, you can, I don't know like if you have to say this or not. Soul can be taken out of one body and transferred to another body. Kada? So you just imagine that I have a soul in my body. So what I do is I take out my soul and transfer to this mouse. So what happens, Sarji? This mouse becomes a monster now. Chusina kada, there are a lot of movies also based on the similar concept. So what happens is the soul enters into car. Soul enters into television. Soul enters into mobile phones, cell phones, andariki. So charge is like a soul and mass is like a body. In physics, we don't say souls. We don't see souls, kada. We only see dead body. So you can say simply charge can never exist without mass. But converse is true. But mass can exist without charge. Ante kada? Good. Example is neutral body ray. Array neutral body ray. Mottam neutral bodies have no charge kada. Next property ra. Next property cheppandi andariki. Dead body. Yes. Yes. Robo 2.0 andariki. 2.0. You చూసుకోండి. In 2.0 what he does is he transfers his soul to cell phones kada. Not cell phones. You can say yes. Cell phones or it is birds ray. I don't know. I forgot the movie. So, you know, all the cell phones, they block the gates of the stadium, kada. So, how did it come, sir? He transferred his soul to another object. So, you can take out a charge from one object and transfer to the other object. You cannot take the mass and shift with another objects. Are you understanding? Charge is a soul. Charge is a soul. Mass is body. Soul can never exist without body, but body can exist without soul. If someone telling you, sir, no, soul can exist, are dayyam ra. We don't talk about that in physics, okay? Andariki. Next, charge is invariant. Ante invariant ante entira or doesn't depend on the speed array. So Sarji, what did you write? Sarji ante, see, this is something known as theory of relativity. What does the theory of relativity say? Sarji, the theory of relativity says mass of the object is equals to m divided by root of 1 minus v square upon c square. So sir, mass depends on the speed. So if you are traveling at the speed of light, your mass will get infinite. Are you understanding? This is the theory of relativity. Kani, it is not the same with the charge. So charge is fixed ra, invariant ra. So imagine na దగ్గర 2 charges undi plus 2 coulomb and here is this charge minus 4 coulombs. So if at all they are moving, let's say it is moving upwards, e charge kindaki veltundi. The motion does not affect the charge. So simply because they are moving, the charges will not change kada. That is what I told. It is invariant. Doesn't depend on the speed. Are you understanding? So even if you are moving 2 charges or 1 charge, its value will not change. Okay. Chalo, next one is additive nature. Yes, additive nature. Or you can simply say charge is a scalar quantity. Any dependence on mass? Charge depended on mass. Is it something like that? No. No, kada? No. No. Scalar quantity and I cannot say like this. Let it be scalar quantity only. So these are the properties kada. Good. Ippudu chusta. Andariki chuskondira. Let's talk about specific charge. What is a specific charge? What is specific charge? Sir, what is specific charge? So specific charge ante now the whole scene of mass also comes into the scenario. So specific charge enti ante sirji, you can simply say specific charge is S S and the value of specific charge is Q upon M. చూసుకోండి ఎప్పుడే నేను చెప్పినా కదా charge never depends on the speed, కానీ mass depends on the speed కదా. So you can simply say, sir, mass is depending on the speed, so this quantity also depends on the speed. So what can I say here is, sir ji, charge does not depend on speed. Sir ji, charge doesn't depend on speed kada. But, it can be asked in the exam, it can be asked, assurance and reason type, but specific charge depends on speed. Cheppandi, write a question, randariki, write one question. What is specific చెప్పండి. So specific charge is equals to, sir, charge upon mass, sir ji. You must know the value of charge Q, and you also must know the value of the mass of electron, If you don't know the value of mass of electron, ante you will be gone, you will be dead. See, you must know the values of constant mass of earth, mass of sun, mass of moon, gravitation on moon, gravitation on earth, mass of electron, charge of electron, mass of proton. Idi mottam, it must be by hearted to you, understanding andariki. Okay, so cheppandi, sir, charge of electron ante 1.6 into 10 to the power minus 19 divided by mass of electron enta, sir. Now I will not tell, I will not tell this value to you. You tell me by yourself. Mass of electron. No, Raju, charge is not independent of frame of reference. I'll tell you later, okay? So, charge is not independent of frame of reference. Or is it independent of frame of reference? Cheppandi. Very good, Raju, very good. 9.1 into 10 to the power minus 31. Very good. So it is 9.1 into 10 to the power minus 31. Chuskondi. So you can do it. Tell me the final answer. Calculator తీసి solve చేసుకోండి అందరికి. Very good, Isha, very good. Very good. So Isha has taken care of all the numbers, so 10 to the power, those minus 31 also. Okay, Sergi, so it is minus 19, this is minus 31. So let's make it upwards, it becomes plus 31. So 31 minus 19 into 12 kada. Good. So the power is 10 to the power 12. But what about this, 1.6 by 9.1. Cheppandi. So you can simply say, sir, that is equals to 16 by 91 kada. You have to do something like this. 4 4s are 16, 4 2s are 8, 11 is there. 4 2s are 8, 3 is remaining, 4 7s are, and this is 4 by 22.75. 1 by Cheppandi, 4 5s are 20. Point it become 27, then it becomes 4 6 are 24. 3 is remaining, 4 8s are 32. You can simply say 1 by 5.68 into 10 to the power 12. Ante. This is the specific charge of electron. Next. Next. Sir, malli cheppandi ardham kale. What did you understand? What did you not understand? Nandini. Em ardham raatledu. Which one? Specific charge ante charge over mass. Ante kada. So specific charge of electron ante charge of electron by mass of electron. Idi charge of electron, idi mass of electron. Substitute chesi, this is the answer. Ante. This is the answer for this. Yes, specific charge is charge by mass. Next. Next time gurinchi maatladtam. What did we discuss next? Let's talk about conductors. Let's talk about dielectric. And let's talk about insulators. Cheppandira. What is conductor? What is dielectric? What is insulator, sir? Arey cheppandi re babu cheppandi. So sir ji, conductor is a metallic object, you can say, and in conductor there are free electrons, valence electrons. So you can move any number of electrons, you can get whatever charge you want in conductors. So conductors ante made of cheppandi, definition cheppandi first of all. Point number 1 kada. Point number 2, have freely valence electrons. Next, can be charged to whatever value. Ante. What about dielectric, sir? Sir, dielectric also has free electrons, but not as much as conductors. So dielectric has a limited number of free electrons. Ante. So sir ji, dielectric has a limited number of free electrons. Next, cannot fully charge. Next example enti ante semiconductors kada, semiconductors are semiconductors. What about insulators? Non-conductors of electricity. So sir ji, no free electrons at all. Next, cannot be charged by induction. Ante kada? You can never charge insulators by induction. By bringing a positive charge, no charge is going to get accumulated. Very good. Only should be charged or only be charged by friction. Ante. Only be charged by rubbing, by charge exchange. By charge exchange. Example, what is the example of it? Plastic, this is a plastic, or rubber, or glass, or glass, etc. Ante kada? Good. So take one question, Take one question. So question is, if two spheres, solid and hollow, option number A, for two spheres, not if two spheres. I'm giving you all by myself, okay? So for two spheres, both can Cheppandi ra. Don't let your energy go down. Cheppandi andariki. Which sphere can hold more charge? Good evening, Anita. Very good evening, Anita. Arey, focus on these questions, re. Don't do some extra stuff, re. Andariki, re. D depends on the radius. D depends on the radius. Raju depends on the radius. Good. No. No. Arey, no, re, Baba. Radius R. Hollow. Radius R. Cheppandi. Now the charge capacity depends on the radius, kada. So you increase the radius, charge capacity. I'm comparing between the two, okay? I'm comparing between the two. Chuskondi, andariki chuskondi. I should change the option itself, right? There is a confusion that, okay? So let's explain both the things. So Sarji, I'm talking about the capacity of holding the charge, right? And these are the conducting spheres, kada. So conducting spheres unte, whatever, chuskondi, observe, andariki, observe, be with me, come on, be with me. When I'm telling that it is a conducting sphere, all the charge that you give externally to the spheres, it will only reside on the surface. What I'm telling? Only reside on the surface. Chuskondi. So if at all you are giving a positive charge, mottam positive charge surface ki ostundi. Ekkada kuda mottam positive charge, it will only come to the surface. So yes, if the surface is more, surface area is more, and charge can be more. Are you understanding? So more charge could be stored. If the surface is less, radius is less, surface area of sphere, surface area is 4 pi r square, chuskondi andariki. 4 pi r square. If the radius is more, surface is more surface ante more charge. If the radius is less, surface is less surface ante less charge. Ante kada? So yes, it depends on the radius of both the spheres. But if both radii are equal, that means both surfaces are also equal, kada. So in that scenario, both can hold same amount of charge. Chuskondi. Andariki, all of you. So charge storage does not depend on solid or hollow. If you have solid conductor, if you have hollow conductor, both scenarios low, the capacity to hold the charge is the same. It does not change. Are you understanding? It only depends on the dimensions and it only depends on the surface area. Ante. Next. What are you typing, Ray? Good. Very good, Andariki. Okay. Next, next topic, what should be the next topic? Electroscope. Electroscope ante entira. Electroscope is a device that is used to check if the object is having charge or not. Ante. That's it. A device used to check if the object is charged or uncharged. Sarji, how does it work, sir? How does it work? నాకు తెలియదు సార్, వర్కింగ్ గురించి చెప్పండి. Okay. So electroscope ante it is a device that is only used to measure if the object is having charge or not. So how does it work ante, let's imagine, I'll tell you the working of it. So we do have a metallic sphere, metallic ball. It is connected to one more metal in a box, and then this is connected to two different plates, right? Two different films. So this is connected to two different films. Ante. Two different films kada. So what happens emaitidi ante, you just bring a positively charged object. So whenever you bring a positive charge, or induction happens, Sarji, induction happening, this negative charge will be accumulated on this surface. So if the negative charge has come up, చూసుకోండి అందరికి, if the negative charge has come up, the positive charge will go down kada. Are you understanding? You bring positive charge, negative charge rises. If this is negative charge, this is your positive charge. So positive charge unte positive repel kada. So they do repel. So there is the repulsion between the films, something like this. So what happens is, koncham samayam tarvata, the scenario looks something like this. So this is now first film, second film, positive charge, ekkada kuda positive charge. Ade. So this is theta. Negative. All of this. You just visualize, okay? So if the films are separated and its object is charged or it's not charged. Ante kada? Very good. Sure. Now, Sarji, ఇప్పుడు we are actually diving into the heart of the chapter. So the chapter starts from here. అందరికి చూసుకోండి. The first main important topic is the Coulomb's law. Sarji, what does Coulomb's law state? It simply says, నా దగ్గర రెండు చార్జెస్ ఉంటే పాజిటివ్ రిపల్షన్, నెగటివ్ పాజిటివ్ అట్రాక్షన్. లైక్ చార్జెస్ ఉంటే రిపల్షన్, అన్లైక్ చార్జెస్ ఉంటే అట్రాక్షన్. అంతే కదా. సో ఇట్ ఈస్ నాట్ ద పార్ట్ ఆఫ్ ద స్టేట్మెంట్. ఐ వాంట్ యూ టు విజువలైజ్. ఇఫ్ దేర్ ఆర్ లైక్ చార్జెస్, చెప్పండి అందరికి, వాట్ హ్యాపన్స్ ఏమైతుంది? రిపల్షన్ కదా. వెరీ గుడ్. సర్జీ, వాట్ హ్యాపన్స్ ఇఫ్ దేర్ ఆర్ అన్లైక్ చార్జెస్? ఏమైతుంది రా, చెప్పండి అందరికి. So unlike charges unte, they do attract. Ante kada. Chuskondi, when I am telling charges, mass is also considered. Andariki, I am telling you, you don't assume just a charge and mass. Don't ignore the mass. Endukante charge can never exist without mass. Understanding? So epadaina I am telling you about the charge, mass is also there. Okay, sir, what does the Coulomb's law states? And it is only valid. Statement number 1. Valid for point charges only. So, sir, what is a point charge, Sarji? What is a point charge? Ante, you just take the definition. Sir, point charge ante the radius or the dimension of the mass is very small. How much small, sir? Very small. Point. Just a point. Are you understanding? Close to zero. The force of attraction. Very good, Nandini. Very good. So simply Coulomb's law aim cheptadi ante the force of attraction or repulsion. Chuskondi. It may be attraction, it may be repulsion. Rendu cases lo this is a valid statement. Force is directly proportional to the product of the charges Q1, Q2. and the force is inversely proportional to the square of the distance between the centers, ante, between the points. Ante kada. So you combine the two formulas and you will get F is equals to K times of Q1 times of Q2 divided by R square. Are you understanding? Good. Now, Sirji, I understood the formula. F is equals to K times of Q1 times of Q2 divided by R square. So let's say this is my first charge, idi na second charge ra, and let's say the distance between them is R. Sir, what is this K, Sirji? What is this K, Sirji? K is 1 by 4 pi epsilon naught. Sir, K ki value anta ante, you can simply say the value of K is 9 into 10 to the power 9. What about unit ray? What about unit ray? Unit of K. Chuskondi unit of K andariki. Units and dimensions అయిపోయింది కదా. Unit of K చెప్పండి. So from here you can simply say Newton meter square per Coulomb square. It must be visible for all of you. K is 9 into 10 to the power 9. Good. Very good, Nandini. Very good. So Sirji, what is this epsilon naught ante, Sirji? This epsilon naught is a permittivity. Permittivity. Array epsilon naught is there, na? So permittivity of, you can take two things. It is permittivity of free space or permittivity of vacuum. Almost the same, right? What is permittivity, Sirji? What is permittivity? Chuskondi. I'll tell you a story, okay? A kotta story. What happens is, whenever you are taking the two charges, the force of attraction or repulsion depends on the medium, ra. Air lo తీసి different force వస్తది, water లో dip చేసి different force వస్తది, honey లో dip చేసి వేరే force వస్తది. So that completely depends on the medium that you are talking about. So why, sir, why the force is dependent on the medium? చెప్పండి. Why the force is dependent on the medium? చెప్పు. ఏం doubt రా? What is your name? Kavita, ఏం doubt? What's the doubt? Good. So Sirji, why the material decides the force? Endukante these are charges kada, and material lo kuda there are free atomic particles, right? Atmosphere, ray, oxygen, nitrogen, gases are there. Oxygen ante oka atom, oxygen lo kuda there are positive and negative charges kada. So this charge somehow somewhere affects the other medium charged particle also. So the resultant is that the medium now tells, hey, I will be deciding now what force these two charges will apply. Are you understanding? So if you are putting the two charges Q1 and Q2 in a medium, Sirji, medium ante enti ante, let's say this is a water or any some other random medium ra. Arey other medium ra. So medium ante it must have its own permittivity. So ante sir, we will talk about permittivity of the medium now, EM. Cheppandi what is force ra? So in this scenario, force is equals to 1 by 4 pi epsilon naught of medium into Q1 Q2 divided by R square. అర్థమైంది అందరికీ? Good. Medium ante it is the permittivity or the permission that the medium gives for a matter to hold a charge, ante. Or it is a permission that the medium gives for the two charges to exert a force on one another. Different medium, different permission. If it's a very complex medium or if it's a very heavy medium, very less force of attraction. If it's a very light medium, very high force of attraction. A heavy and light, I'm talking in terms of electrostatics, huh? It's not about mass. Next. So Sirji, relative permittivity undara? Relative permittivity. Sirji, relative permittivity ante epsilon r, it can be given as permittivity of medium by epsilon naught. So sir, what did I say? In a medium, Are cheppora, inside a medium, the force F is equals to 1 by 4 pi epsilon of medium ra into Q1 Q2 divided by R square kada. So sir ji, na daggara epsilon R is there. I know the value of relative permittivity. Are cheppo Kavita, what is the doubt, madam? Tell me, Kavita, what is the doubt? And epsilon naught value also I know. So ekkad nunchi what I can say is epsilon of medium is equals to epsilon relative into epsilon naught kada. You lift, you throw, and you take the formula 1 by 4 pi epsilon naught epsilon relative ra, or epsilon relative multiplied by Q1 Q2 divided by R square kada. Good. So sir ji, I am going to rewrite this equation. Ela rewrite chestaru ante, you take out 1 by epsilon relative outside and you simply say force in a medium kada. It is completely force in a medium. So force in a medium is equals to 1 by 4 pi epsilon naught into Q1 Q2 upon R square. Are chudandi ra, this term, are what is this term re? Are what is this term re? Are this term is force in air kada. Or yes, I got it ra. So that means sir, instead of going through this whole complex method, I got a shortcut. What is the shortcut ra? Force in a medium is equals to 1 by epsilon relative into force in air. Ante kada. So you can simply say sir, force in medium is equals to force in air divided by epsilon relative. Ante. So now if epsilon relative is heavier, then force is less, or epsilon relative is low, force is more. Kavita, they will not give you the value of permittivity of medium, okay? You don't also have to remember. They will give you the value of epsilon relative. 100% of the cases, they will give you the value of epsilon relative. What you have to remember is only epsilon naught value. Or epsilon naught value ra. Epsilon naught value, how much rate is? 8.85 into 10 to the power minus 12. Check cheskondi. Now unit, I want all of you to write the unit of it. Epsilon naught value you have to remember, and you have to, you don't have to remember anything else. They will give you epsilon relative. So epsilon naught unte, epsilon relative also they will give you, and you can easily calculate epsilon of the medium. Ante kada. You don't have to remember Kavita, you only have to remember the value of epsilon naught for air or vacuum. It is 8.85 into 10 to the power minus 12. Ardhamaindi andariki. Next. Let's say the distance is 3 meters. This charge is 10 to the power minus 2 coulombs. And each charge ante you can say 4 into 10 to the power minus 4 coulomb. Cheppandi. Andariki cheppandi. Option A. అందరికీ చెప్పండి 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 చెప్పండి. Re. Cheppo. So now you can simply apply Coulomb's law. F is equals to K Q1 Q2 upon R square kada. So force is equals to substitute K is 10 into 9. Q1 value entara 10 to the power minus 2. Q2 value entara it is 4 into 10 to the power minus 4 divided by R square ante 3 square kada 9. So 9 cancel ra. So this is 4, this is 9, this is minus 2, this is minus 4. So 9 minus 6 ante 3. Option B kada. Good. Now let's talk about చెప్పండి అందరికి. So superposition of forces kada. How will I write? So you can simply say surge net force F is equals to F1 bar plus F2 bar plus F3 bar and so on and so forth. Ye daina number of forces are there. You can add them in a vector form ra. Andariki. Yesterday itself we discussed about the vectors kada. So now you must be able to add the things in a vector form. Chalo. So I am taking this question now. Ippudu chudandi andariki. So let's say this charge is 2 into 10 to the power minus 4 coulomb ra. This charge is 4 into 10 to the power minus 4 coulomb. And this charge ante, you can simply say, what should I take? A C 3 meters 3 meters 3 meters. So the question is teeskondira ee question teeskondi andariki and try to do it, all of you try to attempt this question. I'm telling you andariki, find net force on charge A due to the remaining charges ra. అందరికీ లైక్ చేసుకోండిరా వీడియోకి. చలో, so let's try to do it. How to do sir? So all are positive charges, huh? All are positive charges. No charge is a negative charge, okay? All are positive. So ante complete repulsion kada in all three sides. So there will be repulsion in all three sides re. Chuskondi. Next. 2, 3, 4 kada. So I'll add one more slide and we'll do it here. So 2 into 10 to the power minus 4 coulomb. Ante kada. Ekkada 3 into 10 to the power minus 4 coulomb. And here the charge is 4 into 10 to the power minus 4 coulomb. Ante kada. This side is 3 meters. Idi kuda 3 meters. And this is also 3 meters. Andarki cheppandi okkasari. So force on charge A kada. This was the charge A. చూసుకోండి, since all are positive charges, all are positive charges, so E charge this charge will exert a repulsing force kada. So force is in this direction. And each charge walla the force will be in this direction kada. Good. So sir ji, if it is a equilateral triangle 3 3 3 cheppandi how much sir enta angle idi kuda cheppandi 60 kada. It is also 60 degrees, it is also 60 degrees. So sir, if this is 60 degrees, so this angle should also be equals to 60 degrees kada. Andariki cheppandi, andariki. That angle is also 60 degrees. Good. So sir, this is my point A, charge A, one force acting in this direction, another force acting in this direction. The angle between the forces is 60 degrees, sir. Let us say, sir, this force is F1. E force ki F2 pilustunnaru. Now, sir, there are the two vectors. Angle between them is 60 degrees. What is the resultant, Ray? What is the resultant? Formula cheppandi. Formula is, sir, net force is equals to root of F1 squared plus F2 squared plus 2F1 F2 into cos theta kada. What is theta? 60 degrees. It is angle between the vectors kada. It is chudandi tail to tail combination untundira. So now cos 60 is half kada. So you can simply say root of F1 squared plus F2 squared plus cos 60 half and this 2 gets cancelled. So I only have F1 F2. Ante kada. F1 ki value cheppandi andariki. What is the value of F1, sir? Sir, F1 is equals to k q1 q2 by r square. K is 9 into 10 to the power 9. Q1 how much, sir? It is equals to 2 into 10 to the power minus 4. Q2 how much, sir? Q2 is simply 4 into 10 to the power minus 4 divided by r square into how much, sir? It is 9. So 9 gone, Ray. 10 to the power minus 4, 10 to the power minus 4 ante 10 to the power minus 8. 10 to the power 9 into 10 to the power minus 8 ante it is simply equals to 10. Ekkada nunchi you teesko this 2 into 4 becomes 8. So F1 ki value enti ante 80 Newton. Idi value of F1. Cheppandi F2 gurinchi cheppandi andariki. What is the value of F2 ra? F2 is also equals to k into q1 into q2 divided by r square kada. What is the value of q1, right? So it is 9 into 10 to the power 9 multiplied by q1 ki value cheppo. It is simply 2 into 10 to the power minus 4 multiplied by q2 ki value, right? It is 3 into 10 to the power minus 4 divided by r square ante simply this length, re. Idi 3 square ante 9. So 9 cancel ra. Ekkada nunchi 2 into 3 ante 6 kada. 6 into this is 10 to the power 9, 10 to the power minus 8 ante 10 to the power 1 ante 60 Newton. Ante kada. Substitute ra. F1 squared ante 80 square re, 80 square plus F2 square ante 60 square re plus F1 F2 ante 80 into 60 ra. Cheppandi andariki. It is 80 square ante 6400 plus 60 square ante 3600 plus 80 into 60 ante again 4800 kada. Good. So it is equals to root of 14,800 andariki. So it is nothing but cheppora how much root of 14,800 kada. So it is 10 root of 148. So if you want even divide by 4 also, right? So you can also take 10 into, not 10 into, it should be directly I am writing, okay? So 20 into root of 37. Newton. This is the net force. Sir ji, I written about the net force. What about the direction, sir? What about the direction, sir ji? What about the direction, sir ji? Good. Very good. Very good. Very good. So sir ji, చూసుకోండి F1 is 80 kada and F2 is how much, re? 60 kada. The force will not be in this exact middle. Why? Endukante 80 is more, 60 is less, so force net will be slightly tilted towards 80 Newton. Endukante it is more kada. So this would be the direction of my net force, F net. Ante kada. This is the superposition principle. చూసుకోండి అందరికి. అర్థమైంది అందరికి? అరే లైక్ ద వీడియో రే, రే లైక్ ఇట్ రే, అరే లైక్ ఇట్ రే. Good. Good, good, very good. Anita, very good. Nandini, very good. Chalo. Hi, Ria. Hi, hi, hi. Hi, Ria. Hello. Now. Are aim cheyalara ippudu? What to do now, re? So, I'll do one thing, Sirji. We will try to talk about this Coulomb's law. In vector form. Alright. What is vector form, Sirji? I'll explain. Don't worry. Don't worry at all. Don't worry. I'll tell you. I'll tell you everything. So, Sirji, let's imagine this is y-axis. This is my x-axis. So, ekkada I am taking two different charges. This charge is q1. This charge is q2. Kada. Now, we'll talk about the position vectors. Okay, Nandini, we will explain it. Once we will do done with this, and then I'll go back and again explain you that. Chalo, chuskondi andariki. So let's talk about the Newton's law in vector form. You remember yesterday I told you about the position vector. Arey, what is a position vector? Position vector is simply a vector joining origin to that point. Kada. So here you do one thing, you draw a vector and you name it R2 bar. Ardhamaindi andariki. What you do is you join this vector and you name it as R1 bar. Andariki cheppandi okkasari. So, Sirji, the force of repulsion between the two depends on this length, kada? This length, this length. Direction gurunchi cheppora. So, that force will be in this direction on Q1 and Q2 this direction. Ardhamaindi andariki. Now, Sirji, I have to talk about force on Q1. So, sir, if this is R2 bar, if this is R1 bar, what can I say, sir? What direction do I have to take, Sirji? What direction do I have to take? This direction, kada, choose kondi. It is the direction of the force, re. It is the direction of the force. So, in this triangle, I'll simply say this is R bar. Cheppandira. Triangle law, gurtunda, yesterday only we discussed. What does the triangle law say? Re? If you have two cycles, add the two vectors, but instead of going reverse, you take the opposite direction for the resultant. So now what can I say is, I can simply say R2 bar plus R bar is equals to R1 bar. Kada? So ikkad nunchi you can simply say R bar is equals to R1 bar minus R2 bar. Andariki chuskondira. So this is the net direction of force in the upward side. What is the direction? R1 bar minus R2 bar. Cheppandi. So force on Q1 is equals to K into Q1 into Q2 into mod of R1 bar minus R2 bar whole square. Ante kada? So sir, it's a scalar quantity, sir. It is not a vector form, sir. So vector form lo ela convert cheyalante, you multiply with unit vector. What did I say unit vector in the last class? Re? Unit vector is nothing but R1 bar minus R2 bar divided by mod of R1 bar minus R2 bar. Ante kada? So you can simply say force on Q1 is equals to K Q1 Q2 divided by mod of R1 bar minus R2 bar whole cube into R1 bar minus R2 bar. Direction kuda ochindi. Ee form lo you can observe the direction R bar is also there. But this is on only the force on Q1 bar. Sirji, what about the force on Q2 bar? Are same thing, re. You just reverse the directions, re. Cheppandi. So you can simply say here force on Q2 bar is equals to K into Q1 into Q2 divided by mod of R2 bar minus R1 bar whole cube into R2 bar minus R1 bar. R2, R1 enti ante these are the position vectors. Position vectors. Very good, Isha. Very good. Very good, Anita. Very good. So you can simply say these are the position vectors of points Q1 and Q2. Ante kada? Good. So yeah. We'll go back to the question. Nandini, chusko. So this is my particles across the vertices of a triangle. Kada? You simply take the two pairs. The force of repulsion will be away. You take these two charges, the force of repulsion will be here. So these are the two forces. Force F1 is 80, force F2 is 80. Ela calculate chestaru ante you just substitute in the formula K Q1 Q2 by R square. Here also you substitute K Q1 Q2 by R square. Q1 Q2 by R square. Q1 Q2 by R square. Ante kada. Once you got it, you apply simply vector resultant formula. Ade. Done. Next. Sorry, you just give your attention here, okay? Let's discuss something about Lami's theorem. Lami's theorem, observe cheskondi. Lami's theorem application is there. What is Lami's theorem, Sirji? So, sir, for Lami's theorem, I'll take that anyhow in vector, okay? In vectors also, we will be repeating it again. So, once our good part is done, then we will be doing Lami's theorem also. So, Lami's theorem, what does it say? Sirji, in Lami's theorem, it simply says, if at all I have odd number of vectors. Yeah. So, Lami's theorem must have Lami's theorem must have odd number of vectors. Point number one. Point number two, it must have all the vectors should be co-initial. Co-initial ante all must start from the same point. Chooskondi something like this, right? Odd vectors kada. This vector is v1, this vector is v2, this vector is v3 ra. v1 opposite angle ante theta 1. Observe cheskondi andariki. v2 opposite angle ante theta 2 and v3 ki opposite angle ante theta 3 kada. So what you can write, if it is a force, if it is velocity, if it is acceleration, if it is momentum, if it is displacement, you can take whatever you want. So it simply says v1 by sin theta 1 is equals to v2 by sin theta 2 is equals to v3 by sin theta 3. And this is my Lami's theorem. Very important theorem. Very important theorem. So let's apply the application of it in one of the question. So na degra, you just imagine I have, what should I take? I have mass m1, mass m, simply mass m, charge q is there, andariki chooskondi. And here also the same thing, I have the same mass m and charge q. What do you think will happen, Ray? What do you think will happen, Ray? If mass m and charge q is there, these two repel kada, these two will repel. Repel aina, what they do is, they will make some angle with one another. So after repulsion, what they do is, they are at an angle of some theta, let's say. So this is my mass m and charge q. Ekkada kuda, this is my mass m and charge q. Cheppandi. Now question is to find the angle theta. Ante kada. So what is the question, right? Question is find the value of theta, re. So, Sirji, to apply the Lami's theorem, it is the best case. So you can apply it, Lami's theorem, and you can solve this question. So, sir, I have to find the value of theta. So to find, and I will have to see the net forces acting on the mass, kada. So, Sirji, the first force that is acting on the mass is mg in the downward direction. Very good, sir. Very good. Sir, the next force that is acting on this mass is in the left side, and I can simply say this is force of electrostatic repulsion. Repulsion. Chooskondi. Length L I am giving you. Okay, in the question only I am giving you the length L. Length L must be there. Okay. So sir this is the repulsion force. Okay, next force enti ante this is a string kada. So this string is holding this mass, right? So there will be tension force in that direction. Ante. This angle is 90 degrees. You don't know this angle kada, and you also don't know this angle. So what to do, sir, now? If I don't know those angles, what to do, sir? What to do, sir? Arey, what to do, sir? Arey, we can do a construction, re baba. You divide this into two parts. So if total theta, and this becomes theta by 2 and this becomes theta by 2 kada. And you also draw one more construction from here. Ra. Chuskondi. If this angle is theta, idi kuda theta kada. And the same thing you apply here also. Right? This is electrostatic force, this is gravitational force, this is tension force. You draw one vertical line. If this is theta by 2, array, this is theta by 2. This is also theta by 2 kada, ante. Ante. So sir ji, this is the value of tension T. This is the value of electrostatic force of repulsion. This is the force mg kada. And the three vectors are there. Take any mass. I'm taking this mass, right? This mass. The first vector is in the right side. Electrostatic force of attraction. What is the electrostatic force, right? You first have to calculate this distance. Cheppandi. Andarki cheppandi. If this is length L and this is angle theta by 2, can I simply say, array, this is L sin theta, array, opposite side. Ikkada kuda this is L times of sine of theta by 2 kada. So what is the total length, re? Total length is 2L sine of theta by 2. This is the total length. Sir ji, force is K, Q1, Q2 by R square. So K into Q1 is Q, Q2 is Q by R square. R square ante 2L sine theta by 2 kada. So 2L sine of theta by 2 whole squared. This is electrostatic force. So this is Fe kada, array, this is Fe. And here it is mg kada. And this is the force, tension force kada. Observe cheskondi. It is 90 degree and this is theta by 2. So total angle becomes 90 plus theta by 2 in this scenario. You can apply Lami's theorem directly. Cheppandi. What is Lami's theorem? Right? And if this is 90 plus theta by 2, what do you think should angle be? This angle be? 90 plus theta by 2 is gone. So can I simply say this angle should be 180 minus theta by 2? Ante. Able to visualize? Array, it's very tough or what, Ray? Array, it's very difficult or what, Ray? Good, very good. Andariki, very good. So what I can say is, sir, I can simply say Fe divided by sine of 180 minus theta by 2 is equals to, cheppandi, opposite force entira mg divided by sine of 90 plus theta by 2 kada. Ante. Sine 180 minus theta by 2 ra. Sine 180 minus theta by 2. What is sine 180 minus theta by 2? All of you, cheppandi. It is sine theta by 2. Good. So sir ji, I can simply say Fe by sine theta by 2 is equals to mg by cos theta by 2. Ante kada. Cheppandi. What is the value of Fe ra? You can simply say, sir, kq square divided by 4L square into sine square theta by 2 into sine theta by 2 and sine cube theta by 2. It is equals to mg by cos of theta by 2. So I got the equation kada. What is the equation you got? I got this equation. You can solve this equation. Anyways, I want you to apply Lami's theorem in this question. Ardham Hindi and Ardham Leda. Good. Hemant Kumar. I hope it's visible, okay? I hope it's visible. Good. What is the time, right? So we will take a break on 7 p.m, okay? Sharp 7 p.m. will be a break. So sharp 7 p.m. Ready. And the class will continue till 9 or 9:15. I'll try to complete the whole syllabus, okay? Okay, sir. let's talk about the next topic now. Ippudu let's talk about electric field. Cheppandi andariki, what is electric field ra? Yes. So what is electric field ra papa? Electric field is the region of influence. Ante. Electric field ante enti ra? Electric field is the influence of a force. Ardhamaindi andariki. You can mathematically say, see, I'll tell you mathematical definition. I will tell you non-mathematical also. Electric field of given charge is the force experienced by a unit charge due to a given charge. For example, andarki chuskondi. Na daggara oka charge q is there, small q is there. What do you think it will do? It will emit the electric field lines in all the directions. I'll come to that. For now, listen. Now I'm bringing 1 coulomb charge close to it. Both are plus charges, okay? Both are positive charges. This 1 coulomb ki charge, when I'm bringing it close to plus q, what happens? It will experience a force kada. And this force is nothing but electric field of charge q. Ante. What is electric field, sir? What is electric field, sir? You take a charge, you bring a unit charge, 1 coulomb charge, close to it. Yedaina force it will experience, whatever force it will experience will be the electric field due to the other charge, Q. Force experienced by this charge, but it is the field of that charge. Force experienced by this charge, but it is force is field of that charge. Are you understanding? Understanding or not? Now, epudu. Try to visualize. I will try to make you understand this, okay? So let's oka story cheptunnanu andariki. Chuskondi. Ramesh and idi ante Suresh. So what happened is, Suresh was looking to Ramesh from very long time. Both are sitting and he is just looking to Ramesh. Are doing nothing, only looking to me. What do you think Ramesh will feel? Suresh is only looking to Ramesh and giving him a little smiles. Looking at Ramesh and giving him a little smiles. What do you think Ramesh will feel? Huh? Are. Cheppandi andariki. Yes. What happens? Okay. So what happens is, what happened? Here is the slide. Okay. So what happens is, let's imagine Suresh is just watching Ramesh and giving him little smiles. It's been 1 hour. It's been 2 hours. 2 hours nunchi he is just watching at me. Ramesh will feel uncomfortable. So what happens is this Suresh, this guy, this idiot, now what he does is he slowly tries to, go close to Ramesh. For example, let's say this is Suresh now in this scenario. He is going close, he wants to talk to Ramesh. Okay, he wants to talk to Ramesh. So what Ramesh will do? Cheppandi. What Ramesh, no one Suresh here in the chat, okay? No one Suresh is there, right? Good. So what Ramesh will do, Ramesh will push him, right? He'll push him. Hut. What happened to my chat box? I'm not able to access the chats, okay? Okay. So what Ramesh will do is he'll push him. Push him, kada ante. He'll push him very hard. So he pushed him and Suresh fell down. Ante. So my question is, how did Ramesh push? How did Ramesh push? How did Ramesh push? Are with his hands, re baba, with his hands, kada, with his hands. Ramesh pushed Suresh with his hands, kada. Yes. Yes. Very good. So how many hands Ramesh has? How many hands Ramesh has? How many hands Ramesh has? 2 hands. 2. Now, Sirji, let's say Suresh fell down and this is the next morning. Next morning, Suresh told his friend, "Arey, that Ramesh is very handsome guy, and he pushed me once and I fell down very badly." So let's say next day what happens is, Suresh also came. Suresh also came and he brought his friend. What should he say? Yogesh, for example. No one Yogesh, right, in this class. Okay. So now what they are doing is, Ramesh is standing in the middle. He is watching him, giving him smiles. He is also watching him, giving him smiles. Where did I come? What to do now? Now there are 2 different problems that I am having right now. Yes, yes. So what are they doing is, again they are coming to talk to Ramesh. They are coming close to him. What he'll do, What he'll do? What he will do, He'll push them both sides, right? He'll push them both. And he has 2 hands, Radha. So because he has 2 hands, because he has 2 hands, he is pushing them. Okay, sir, this day also gone. Next day there are 4 different people. What will Ramesh do now? So if there are 4 different people, what will Ramesh do? He has only 2 hands, Gada. How will he handle it? Understanding? So Ramesh needs 2 more hands. 2 more hands, 2 are already there. He needs 4 hands. And are you understanding? So why is he using his hands? He is using his hands to push the other person. Are you understanding? Are you understanding? Are you understanding? He is using his hands to push the other person. Same thing happens in case of charge also. So let us say this Ramesh is charge plus Q or plus Q1. Separate name kada. Suresh ante this is a person plus Q2. And this Yogesh ante this is a charge plus Q3. So what you are doing is, you are trying to bring these 2 charges close to one another. So what this is doing, Q2 is watching this charge Q1. Similarly, Q3 is also watching charge Q1. He is getting embarrassed. Are you understanding? So what he'll do is, he'll push them both. But the biggest benefit is that Q1 has how many hands? Ramesh had 2 hands. But in general, a charge has how many hands? Cheppandi andariki. In general, a charge has how many hands? A charge has infinite hands. Infinite. Are you understanding? A charge has infinite hands. So that means, what does that mean, what does that mean? Cheppandi. What does that mean? What does that mean? If a charge has infinite hands, that means it will be able to handle infinite charges in whatever direction they are coming from. Because it has infinite hands, kada. So he'll push them, all of them, in each and every direction. In each and every direction, kada. Something like this. Good. Very good. Very good. So that hand of a charge, is it visible to you? Can you see that hand of a charge? Hand of Ramesh, it's visible to you. My hands, they are visible to you. But the hands of a charge, are they visible to you? No. Not visible, kada. So the hands of a charge are not visible to you. And invisible hands, we call it as fields. Are you understanding? Invisible hands ante fields. Are you able to understand this? Invisible hands ante fields. Are you understanding? Invisible hands ante fields. Now, Sirji, if it is a charge, then hand of a charge is known as electric field. If it is a mass, then hand of a mass is known as gravitational field. Are you understanding? If it is a magnet, then hand of a magnet is known as magnetic field. I hope you are getting till this point, right? Good. Next. Sirji, now let's talk about field hands of a charge. Okay, hands of a charge. You remember, now I am telling you about the hands of a charge. How many they are, how are they looking like, and all these things. So you talk about my hand, it is 2 hands are there, 5 fingers are there, total 10 fingers and all these things. So let's talk about hand of a charge. Ante it is field kada, or properties of field lines. Number 1, it is the rule set by nature. What is the rule, Ray? A positive charge will always try to push. Are you able to understand? A positive charge will always try to push away. So that means the hands of a positive charge are always going away from it, kada? Similarly, you can say for a positive charge, the field lines are always going away from the charge. These are the hands of a charge. Infinite hands, okay? Infinite hands. For a positive charge has always tendency to push away things. A very irritated person, a very depressed person, you can't come and sit to him. He'll try to push you all the times. What about the negative charge, Sirji? Negative charge unte, he'll try to attract, he'll try to pull everyone towards himself. Are you understanding? He'll use his hands to pull everything towards himself, right? So all his hands are directed towards himself. So for a negative charge, the field lines are always directed towards itself. For a positive charge, field lines are away from it. For a negative charge, field lines are towards it. Point number 1. Property number 1. Next, property number 2. Cheppandi. Field lines don't form closed loops. Number 3. So electric field lines never form closed loops, okay? Never ever they form closed loops. Magnetic field always exists in closed loop. There is one more thing that we will be studying, induced electric field. In magnetism we will be studying. I don't know if it's there for you or not. Let it be. So electric field lines, they don't form closed loops. Next, third property, electric field lines do not intersect. So that means, Sirji, if it's a positive charge, if it's a negative charge, or let's say both are positive charges, the field lines are away, the field lines are away, the field lines are away, something like this, kada? Something like this. So something, no, it never happens. Why? These positive charges don't like to shake hands, Ray. No handshake is there. Are you understanding what I'm telling? The two hands, they are not Nokia not shaking the hands. Are you understanding what I'm telling? No. This is not there. How should I tell you? They don't intersect, okay? Don't intersect. Wrong. So what happens instead is, if you bring two positive charges, their field lines are emitted, but at the same time they will reverse back because of there are other field lines, kada? So like this. So they'll curve, they'll take a sharp turn outside. Positive charges have field lines something like this. Ante kada? Are you understanding? This is the right representation. Next, How many properties, right? How many properties did we see? 3 kada. Now fourth property, choose kondi. The intensity of field is directly, or nahi, not, I should not say that, is more if more field lines are there. And vice versa. So what does it mean, sir ji? It means simply thing, you just observe it, okay? So if I am asking you electric field at point A and electric field at point B, choose kondi. At what point the fields are more close, right? At what point the fields are more closed, A or B? So you can simply say electric field at A will always be greater than electric field at B. These are all the basic properties I want you to understand. Good. Next. Fifth one. The tangent at any point gives the direction of electric field at that point. So sir, what is this, sir? What are you telling, sir? Choose kondi. So if this is a positive charge and if this is also a positive charge, choose kondi. What happens is these two will have the field lines in this direction kada, something like this. Actually this is called null point, okay, but I don't know if you remember. This. These are the field lines. Andariki, choose kondi. Now what I am doing is I am going to draw a tangent. On this point draw a tangent. This is the tangent kada. So this is the direction of electric field at this point. Similarly, draw a tangent over here also. Cheppandi. This is the direction of electric field at that point. Are you understanding? Ardhaminandariki. Chalo. Yes, Hemant Kumar, I totally agree. సార్ మీరు ఏమో ఫిజిక్స్ గురించి ఎంతగా చెప్తున్నారు, అక్కడ అఖండ 2లో బాలయ్య ఫిజిక్స్ ని కిల్ చేస్తున్నాడు సార్. వెరీ గుడ్. ఓకే చూసుకోండి. నెక్స్ట్ ప్రాపర్టీ రా. హౌ మెనీ ప్రాపర్టీస్ ఆర్ దర్? 5 కదా. నెక్స్ట్ ప్రాపర్టీ నెంబర్ 6 చూసుకోండి. ఎలక్ట్రిక్ ఫీల్డ్ లైన్స్ ఆర్ perpendicular to surface. Charge, or you can say conductor also. So sir ji, నా దగ్గర ఒక చార్జ్డ్ ప్లేట్ ఉంటే, ఫర్ ఎగ్జాంపుల్ ఐఎమ్ టేకింగ్ ఎ చార్జ్డ్ ప్లేట్ రా, అందరికి చూసుకోండి. సో ఇఫ్ అట్ ఆల్ ఐఎమ్ టేకింగ్ ఎ చార్జ్డ్ ప్లేట్ రే, let's say positive charge is there on this plate ra. Cheppora how the field lines will emit re. Can I say the field lines are perpendicular to the surface, sir ji? Yes, you can say that. These are the electric field lines. Ekkada kuda and here also. E bar. Ante kada. Next, property number 7. What does it say re? Inside an isolated conductor, isolated ante entira, isolated ante if it is a charge or it is uncharged, isolated closed conductor I should say. Inside an isolated closed conductor, field is 0. So Sarji, if you have a sphere and you give a charge of whatever charge, edina charge you are offering to it, the inside field is always 0. Ante. Field inside is 0. What are you typing? Re? Next, how many properties? 7 kada. Next property 8. 8 property choose kondira. What should I say? It never takes sharp turn. Ante Sarji positive charge, field line sharp turn. It is not there. You can't see these sharp turns. Wrong. Are you understanding? Are you understanding? What happens is they'll take a smooth turn. Oh, very perfect smooth turn. Something like this. I hope it's visible to you. Okay. It should not intersect. Or else you'll understand, sir, you have also intersected the field lines. No. But you go there. But sharp, no sharp turns, smooth turns. And the last property number 9 is electric field is conservative. That means total energy is constant. Okay. Sarji, ఇప్పుడు we will try to see. What I'll try to say, చూసుకోండి అందరికీ చూసుకోండి. Electric field due to a point charge. Electric field due to a point charge. So, ఏంటి Sarji, electric field due to a point charge అంటే, you simply imagine you have a point charge Q. And sir, I want electric field here also, and here also, sir. 4 points I want the electric field. చూసుకోండి. If you want the electric field at this point, positive charge kadara, positive charge unte the field lines will be directed away from the charge. Ekkada kuda, if you want here, it will be away from the charge, radially away. Here also the field lines will be away from the charge, something like this. And ekkada kuda, here also the field lines will be away from the charge. Ante kada. Kani the field lines depend, or the value of the field depends on the distance. So let's just imagine this distance ante R1, this distance ante R2, and this is ante R3, and idi ante it is R4. Chuskondi. The field ante you can simply say E1 is equals to KQ by R1 square. Here tell me the field. What is the field? KQ by R2 square. Here tell me Cheppura E3 is how much? KQ by R3 square. Here Cheppura E4 is how much? E4 is equals to KQ by R4 square. So that means due to a point charge, Q, electric field at a distance, at a distance R is given by E bar is equals to, or E is equals to KQ by R square. Observe cheskondi, electric field is a vector quantity. Ante, are you understanding? So you can simply say E bar is equals to KQ by R cube into R bar. Are unit vector, I just multiplied it with unit vector. Ante. Are you able to understand, Andariki? You're saying something. Whew. Chalo, next. What should I say? What should I write next? Okay, now we'll try to superposition of electric field. How many time is there? What is the time? 7, exact 7, sharp 7. Okay, break. let's meet after the break. Hello, 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 hello. All are there? Andariki present? Okay. So let's continue, everybody. Yes. Late, yeah. I'm sorry, I'm so sorry. 5 minutes late. I got 5 minutes late, Ray. But it's okay, chalta hai. You know, it's not a court, right? It's not a court. It's a class. It's a regular class. So if it's a court, then a judge can ask me, why are you late, Ray? Why are you late? Chalo. Now, we'll continue, Ray. Then continue. Let's continue. Continue. Just continue. What did I say, Ray? In the last class, in the last portion of this live, we discussed about the field, kada, field due to a point charge. Oh, sorry. It's RQ. Now we'll talk about superposition of field ray. Array, superposition of field ray. Superposition of field, sir. Superposition of field enti ante, you can simply say the net field due to multiple charges is vector sum of the independent charges field E1 bar plus E2 bar plus E3 bar and so on and so forth. So sir G, for example, how many people are watching live? All of you like the video, andariki like the video. Like cheskondi andariki. Like, comment, share to get the latest updates on this channel. Okay. So what you can say is, so sir, let's say this is my first charge Q1. Sir, this is my second charge Q2. And sir, this is my third charge Q3. And I want the field at this point. So let's say, sir, this distance is R1, this distance is R2, and this distance is R3. Are you understanding? So, Sirji, how will I write the net field? Ante, you write the independent fields. So, first is E1 bar due to this Q1 charge. Second is Q2 charge field line will be directly away from it and I will say E2 bar. And third, I will simply say this is E3 bar. Are you understanding? E3 bar. So, you can simply say E net bar is equals to E1 bar plus E2 bar plus E3 bar. For example, sir, let's take a question. So, the question says something like this, sir, na degra 2 points are there. So, let's say this charge is Q1, it is equals to 2 into 10 to the power minus 2 coulombs. Visible kada? E charge ante Q2, it is equals to 4 into 10 to the power minus 2 coulombs. Sir, let's say the distance between the two charges, it is equals to, chuskondi. So the distance between the two charges is 6 meters, sir G, and I have to find the field at this point. Chuskondi andariki. So sir, find the field at this point. What is the field at this point? So this distance is 8 meters. So this is point A, sir. So the question says, find the net field at point A. Ela find cheyalanta. What to do now, sir? You simply do one thing, sir. You try to take this field line. Mistake aindi. So, try to join this line. So, this is field line number 1, E1 bar. Slightly shifted down. Yes, like this. Now it's good. So, Sirji, this is my field E1 bar. And what about the other field, Sirji? The other field E2 bar will be something like this. Idi kada? Yes, E2 bar. So, sir, if this is 8 meters, should I take 8 or 4? I should take 4 rather than 8. Okay, so it should be 4, okay? For better answer. Chuskondi. Cheppandi andariki. So, if this is 3 and if that is 4, what is this angle, sir? If this is 6, so this is 3 meters. This is also 3 meters kada. Midpoint re. 6 ki midpoint ante 3. So chuskondi, this angle will automatically become 37. I know it, you don't know it, that's why I'm telling to you. If you know it, well and good. If you know this angle ray, well, very good. Let's say this is 37 degrees. I know, that's why I'm telling you. This is also 37 degrees. Endukante 3, 4, 5 sides are there. So by Pythagoras theorem, you apply 3 square plus 4 square will be 5 square kada. So you can simply say this is 5 meters. And idi kuda you can say this is also 5 meters. Andariki cheppandi. So you calculate the value of E1 first and then you calculate the value of E2. Cheppandi andariki E1 is equals to K Q1 divided by R1 square kada. K value ante 9 into 10 to the power 9 into Q1 ki value entira. Q1 ki value ante 2 into 10 to the power minus 2 divided by R square. What is R square? R square is 5 square kada. So 5 square is 25. Ante. So sir, 9 2s are 18, 18 by 25. Sir ji, it is 18 by 25 multiplied by, cheppandi, 10 to the power 7 kada. Good. Similarly, sir, let's try to calculate the value of E2. Cheppandi andariki. This is the second charge. The field line E2 will be in this direction. Chooskondi. What is the value of E2? Sir, again it will be K into Q2 divided by R square. What is the value of K, sir? 9 into 10 to the power 9. What is the value of Q2, sir? It is 4 into 10 to the power minus 2 kada. Good. Divided by R square and again it is 25 kada. So now it becomes 36 by 25 into 10 to the power 7 again. Ardhamaindi kada? Good. Sir, I think I can make an approximation. What is the approximation ante? You see, it is 18 by 25. E1, 18 by 25. E2 is 36 by 25. Can I simply say, sir, from this part, can I say E2 is equals to 2 times E1? Yes. Are, why are you writing re? It will be helpful as hell for me to calculate the net field ra. So first field is E, E1 is E, the second field is 2E. Chooskondi, the first field is E, the second field is 2E kada. Okay sir, now I have to do the superposition and I will have to add the fields independently. So, idi na value E, this is my 2E, cheppandira. If this is 37, this is 37, mottam angle entara? 74 kada, 37 into 2 ra, 74. Great. So, sir, this is total angle 74, idi kuda 74 ostundi kada? Yes. Okay, sir. This is 74 angle. So, what should I do, sir? For finding the net field, I will have to apply the formula. E net is equals to root of E1 square plus E2 square plus 2E1 E2 into cos theta. Cheppora. E1 square is simply E square plus E2 square is 2E square. 2E whole square ante 4E square ra. Plus 2 into E1 is E. E2 is 2E into cos 74. Oh, boah. What is the value of cos 74? I will tell you. Chooskondi. It is equals to 2 into cos 37 kada. Cos 37 entara 4 by 5 whole square minus 1. So it is 2 into 16 by 25 minus 1. So 32 by 25 minus 1 ante 7 by 25. Cos 74 is 7 by 25. Andariki chooskondi. I am writing the value here. Cos 74 is equals to 7 by 25. Chooskondi. Cheppandi. So it is root of 7 by 25 kada. 2 into E into E2 into cos 7 by 25. Andariki chooskondi. So it is E square plus 4E square ante 5E square plus 4E square. Chooskondi. 2 into 2 4 E into E square. So 4E square into 7 by 25. Andariki. Ardhamaindi? I'll do one thing. I'll remove it from here. And I'll write the same thing here. 2E2. So from here, andariki E square I will take common and I'll take it out of the root sign. So I'll left with root of E into 5 plus 28 by 25 andariki. So it is equals to E root of 28 into 5 ra. How much? Entara? 28 into 5. 140 kada? 140 plus 28 ante 168 ra. 168 by 20. Should be 28 by 25 kada. So it is 25 ra. So 125 plus 28 re. 153 ra. 153. So it is E into root of 153 divided by 25. So you can also say, sir, the value of E. What is the value of E, sir? This. This is the value of E. So 18 by 25 into 10 to the power 7 into root of 153 by 5. Ante. So idi na net field. Ardhamaindi. This is known as the superposition of field ra. Now let's talk about what are we talking about andariki. Okasari cheppandi. Yes. Yes, చూసుకోండి. Next topic is electric field E bar due to ring. అరే రింగ్ లో ఎంత పాయింట్స్ ఉంటుందిరా? There are multiple points at which I have to find the electric field due to ring ra. So the first point I'm telling is, let's imagine idi na ring, something like this. Let's say the radius is r, and from the center I'm going x distance andariki. Let's say plus q charge is distributed on this ring. Andariki చూసుకోండిరా. So plus q charge unte, you can simply say at a distance x ray, if the radius is r, if this distance is x, Sarji, what is the net distance? What is the net distance? What is the net distance? I want the field at this point. Let's say point P is there. So I have to find electric field at point P. You just remember the formula. Formula enti ante, sir, you take this distance comes out to be root of x square plus r square. So field is simply equals to kq into x divided by x square plus r square to the power 3 by 2. Ante. This is the field at a given point. What is the direction, sir? What is the direction, sir? Direction into the direction of the field will be away from this part. Similarly, you take the symmetry. Symmetry తీసి you come at the same distance this side also. So A side lo వచ్చి, if you want the electric field at the same point P ra, same conditions are there. You take this distance also. Again, this will be root of x square plus r square. And about the direction, if you are considered or if you are concerned, you simply take the direction, it will be away. So these are the direction of electric field lines from a ring. Away from each other, andariki చూసుకోండి, away from each other. Good, very good. So Sarji, let's talk about the graph, sir. So if this is my ring, sir, if this is my ring, the field inside the center is 0. చూసుకోండి అందరికి. The field inside the center is 0. Are you able to understand? And where the maximum field is there ante, if you increase the value of x, if you are increasing the value of x, the field also increases. If you increase the value of x, increases, and there comes a maximum value of field. At what distance, Sarji? At a distance of, చూసుకోండి అందరికి. So at a distance of x is equals to r by root 2. అందరికి. So at this distance, what distance, right? Field is maximum, are in both sides, right? In both sides. Ante, if this distance is x is equals to r by root 2, the field is maximum at this distance. Are you understanding? And from here the field will get less, something like this, decreasing. So sir, ekkada kuda the same thing is happening. The field is maximum value at x is equals to minus r by 2. Minus r by root 2. This is the graph of electric field versus distance ra. చూసుకోండి. It is the maximum field. Highest point and lowest point kada. Maximum distance చూసుకోండి. Maximum distance is there. So you can say these are the maximum field points. Now, sir G, I am interested to talk about the electric field on a plane of the ring. So sir, if you are distributing a charge of plus q, sir, what is the field at the center? So you can say it is electric field at the center, always 0, not in the center. Ekkadaina, wherever you take the electric field, at all these points, the electric field is 0. E is equals to 0. Ante, finished. At each and every point inside the plane of the ring. Plane of the ring, అర్థమైంటుందరా? చూసుకోండి. If this is a ring, how should I tell you? If this is a ring ra, it is a ring kada. So at each and every point, field is 0. Are you understanding? Field is 0 in each and every point. Done. Okay. Next, we'll talk about semicircular ring ra. What is the field, sir? Field is simply equals to 2kq by pi r square. at the center, electric field at the center, EC is equals to. And what about the direction, Sirji? The direction is straight away from the ring. Similarly, if you are talking about the electric field at a general part of the ring, arc of the circle or circular arc ra, chuskondi. Circular arc tisi, what you can say is, if the total angle is theta, then the field at the center of the circular arc, here, ekkada, electric field at the center is equals to, formula chuskondi, it is kq by r square, q ante total charge kada, plus q, ekkada kuda plus q, cheppandi, into sine of, I should write here, this is EC kada, this is electric field at the center. So electric field at the center is equals to kq by r square into sine of theta by 2 divided by theta by 2 ante. So this is the electric field at the center of the ring. Ardhaminda andariki. Next we will talk electric field due to spheres. We are not here. Let's discuss it later on. Chuskondi. Question. You take a question. Find electric field at point O. This is 120 degree angle. 120 degree angle. Q is equals to 4 Coulomb charge, radius R is equals to 2 meters. Cheppandi andariki. What is the formula? It is the arc of a circle kada. So arc of a circle, what is the formula? Andariki cheppandi. What is the formula, Sirji? The formula is simply this. E bar at the center or E bar at O is equals to kq by r squared into sine of cheppandi andariki theta by 2 divided by theta by 2 ra. What is the value of theta? 120 degree, 120 degree, 120. You must express this in radians. So 120 ku radians lo express chesi, what will you do? Multiply by pi by 180. I told you earlier also. 0, 0 cancel, 6 2s are 12, 6 3s are 80, ante 2 pi by 3. Theta is equals to 2 pi by 3. Andariki. Substitute cheskondi. Field is equals to kq by r square into sine of 2 pi by 3 by 2 divided by 2 pi by 3 by 2. Ante kada? So it's pi by 3. So you can simply substitute the value. K is 9 into 10 to the power 9 multiplied by q value ante 4 divided by r square is again 2 square ante 4 multiplied by sine of cheppandi pi by 3 sine 60 kada, sine of pi by 3 anta, sine of pi by 3 anta, root 3 by 2. So it is root 3 by 2 divided by pi by 3 kada. Good. So Sirji, 4 cancel, 9 into 10 to the power 9 into, you take that 3 upwards. So it comes out to be 3 root 3 divided by 2 pi. Ante. So this is the electric field formula. Next. Nana, now we are going to come at a very important topic. Okay, andariki okkasari observe cheskondi. Very good, very good, very good, very good, andariki, very good. Chalo. Now we will talk about something known as electric flux ra. What is electric flux ra? You can simply say number of field lines, electric field lines, number of field lines passing in a given area. So let's imagine, students, if this is my field line, okay, if E is my field line, andariki chuskondi, and if this is a circle, circle area entira, if the radius is R, andariki chuskondi, if the radius is R, what is area ra? Area is equals to pi r square. And what is electric field? Electric field is equals to E. So if I have to talk about flux, చూసుకోండి, area is a vector quantity. Area is a vector quantity. అందరికీ చూసుకోండి. Area is a vector quantity. So ante it also has magnitude and direction kada. So ఏంటి direction sirji? Direction is perpendicular to the surface. అంతే. Next, point number 1. Point number 2, area గురించి మాట్లాడుతున్నా. So it is area. Everything about area. For third, point number 2, 3. For closed figures, for closed shapes, or you can simply say for closed objects. For closed objects, net area vector is 0. For closed objects, net area vector is 0. For example, na దగ్గర ఒక sphere is there. So if at all you have a sphere, the total area is 4 pi r square kada, if the radius is r. But it is only in terms of scalar number, we are adding the area. But when you talk about the area vector, it is equals to 0. ఎందుకంటే చూసుకోండి, addition చూసుకోండి. You take small area dA, it is away. You take exact opposite small area dA, it is away. Opposite directions kada, same values, opposite direction cancel out. Similarly this cancel out. Similarly this, and you can say this cancel out kada. Everything cancels out and net area becomes 0. Get it? Now let us say flux phi is equals to E bar dot A bar. What do you mean by E bar dot A bar? E bar dot A bar ante it is equals to E into A into cos theta. Case number 1. E bar, it is parallel to A bar. What is E bar parallel to A bar? E bar is in the right side. E bar is in the right side. అందరికి చూసుకోండి. And area vector is also in the right side. Area vector అంటే ఏంటిరా? Area vector is a vector always perpendicular to the surface kada, and this is na area vector. చూసుకోండి అందరికి. So this is my area vector and this is my electric field vector, E bar. E bar same and A bar also same. Parallel kada. Case 2 చూసుకోండి. What is case 2 ra? Case 2 is E bar is perpendicular to A bar. E bar is perpendicular to A bar. E bar is perpendicular to A bar. So in that case, flux is equals to E bar dot A bar ante 0. ఎందుకంటే the dot product of the two perpendicular vectors are 0 kada. Good. So what is the example for this, Sirji? You can simply assume your electric field is in this direction and your area is something like this. చూసుకోండి. I should change my pen, right? Okay. So this is my area. So this is my area and this is my electric field. చూసుకోండి. Perpendicular kada. 0 dot product. And third case, ఈ scenario లో E bar parallel to A bar kada. So flux is equals to simply E into A. అందరికి చూసుకోండి. In this case, case number 3, general scenario. So general scenario లో ఏమైతుంది అంటే your field lines are something like this. Observe చేసుకోండి. Little tilted kada, and your area vector, I should change my pen for area array. Yes, and my area vector, it is exactly in the right side. So in that direction, area is this and your electric field is this. Ante kada. Now you have to take this angle as theta. Now you can say flux is equals to E bar dot A bar ante E into A into cos theta. Cos theta ra. Cos theta. అర్థమైంది? So these are the 3 cases in which you will have to understand. Good. Now let's talk about one of the most important laws in electrostatics, Gauss law. అరే ఏం చెప్తుందిరా ఈ లా? What does this law say? It simply says flux through a closed surface is equal to inside charge by epsilon naught. Ante. What does it mean, sir G? It simply says phi is equals to Q inside by epsilon naught. Sir, what is phi, sir? Phi is E bar into A bar kada. So you can simply say E bar dot A bar is equals to Q inside by epsilon naught. Or leda, if it's a closed figure, you can also write E bar dot dA bar, it is equals to Q inside by epsilon naught. Let us take an example. Example చూసుకోండి అందరికి. Sir, if I have a charge Q and it is placed in a cube, చూసుకోండి అందరికి. This charge Q is actually placed in a cube, but it is placed inside a cube. So, ఇది నా charge, చూసుకోండి. Inside kada. Let us say the length of the side of the cube is A. అందరికి చూసుకోండి. How much ra? A kada. What is the total area of the cube ra? What is the total area? 6 faces are there. 6 faces are there. ప్రతి ఒక్క ఫేస్ కి ఏరియా అంటే A square and 6 faces are there. So you can simply say E into 6A square. It is my total flux kada. అర్థమైంది? So what you can say, sir G, electric field E into 6A square is equals to Q inside by epsilon naught. అందరికి చూడండి. So from this point you can simply get electric field is equals to Q divided by 6A square epsilon naught. అర్థమైందా అందరికి? All of you, tell me. So sir, this is the electric field at a given distance. Next, we will talk about infinite wire. Infinite wire, చూసుకోండి అందరికి. Infinite wire. So sir, the length is infinite kada. Kani, I will tell you something. Linear charge density ra. Are linear charge density. What is linear charge density re? What is linear charge density? Linear charge. I can do one thing. Are not infinite. Let's do one thing. Let's take a general case. Simply wire. Let's take about a wire. Let us take about a wire. Chuskondi. So if it's a wire, electric field due to a straight line. Electric field due to wire. Chuskondi. Andariki chuskondi. Let us say the length of the wire is L. And ఈ మొత్తం వైర్ పై I am distributing a charge of plus Q. అందరికి చూసుకోండి. I am distributing a charge of plus Q. అర్థమైందా? Now, Sarji, how do the field lines are emitted into it? How the field lines go ante, the field lines are always perpendicular to the wire kada. The field lines will be emitted in all the directions. Something like this. చూసుకోండి. ఇది. ఎక్కడ కూడా these are the field lines. All of you. Observe చేసుకోండి. So if this is a wire, sir, if this is a wire, the field lines are all the directions kada. They are in all the directions. Something like this. Everywhere. So how should I cover them, sir? I have to construct a cylinder kada. So I will have to construct a cylinder around this wire. So sir, let's do one thing. I will cover all the field lines, but I need a cylinder around it. So let us draw a cylinder. Ade ee cylinder ki we will be calling it as Gaussian surface. Okay. So this is my cylinder kada. Let us imagine the radius of the cylinder is R. Andariki chudandi. This is R, idi kuda R. The total length is L kada. The total charge is Q. Cheskondi. What you'll get, right? What you'll get, if let us divide one terminology, we will say the total terminology is equals to lambda. Linear charge density. Lambda ante total charge per unit length. So total charge is Q, total length is L, lambda is simply equals to Q by L kada. Good. I will be using this linear charge density term in infinite wire. Ikkada just observe cheskondi. Sir Ji, the field lines are traveling in this way. All the field lines have been covered. Something like this kada. Cheppandira, what does Gauss law states? it states total flux is equals to Q inside divided by epsilon naught. Are yanta charge ra is sphere lo capital Q charge kada. Good. So you can simply say capital Q by epsilon naught. Eppudu I will have to find the value of flux. Flux find cheyadaniki I will have to find the value of electric field ra. Let us assume the electric field is E. So you can simply say E into the curved surface area of cylinder. Curved surface area of cylinder. Entara 2 pi r into h. H ante how much? L kada. Ardhamaindi. So now, sir ji, you are getting electric field is equals to Q divided by, you send everything that side, ra. You send everything that side. 2 pi r into L. Ardhamaindi. Are you understanding this? So, sir ji, let us do one thing. Divided by epsilon naught is there, you multiply it. So, sir, I will multiply numerator and denominator by 2. What am I getting is 2Q divided by 2 2s are 4. I will write this pi. This epsilon naught I am rewriting. This epsilon naught I am rewriting. Epsilon naught here multiplied by total length L into the radius R kada. R ante the distance or radius of the wire. Yedaina it is. Sir ji, you try to visualize. It is 2 kada, 1 into 2. So now I am trying to separate the terminologies. What are the terminologies? This is 1 by 4 pi epsilon naught K. Sir, this terminology, this Q by L, Q by L, what is Q by L? Q by L is lambda. Substitute. So you will get 2 is 2 into K is K into all this becomes lambda divided by what is this? This is R. So this is electric field due to a wire. Observe cheskondi. So even if it's a wire or even if it's an infinite wire, the electric field is how much? 2K lambda by D. Ante. Are you understanding? So na daggara oka infinite wire unte, you want the electric field at a general distance D kada? D. The field line number 1, it is directed away from the wire, something like this. And the value of electric field is 2K lambda upon D. What is lambda, sir? Lambda is the linear charge density of the wire. It will be given to you. It will be given to you. It will be given to you. Linear charge density will be given to you. Good. Very good. Next, we'll talk about electric field due to infinite shield. It's there for capacitors. Okay, the next chapter. Chudo infinite sheet. So, ela solve cheyala sir ji, na daggara oka infinite sheet undi. Infinite is a relative terminology, okay? For an ant, an elephant is an infinite shape. For you and me, an elephant is not an infinite shape, kada? Good. So, sir, I have distributed plus Q charge. Sir ji, let's say the sigma is entira. It is aerial charge density. So what do you mean by aerial charge density, sir? Sigma is equals to charge upon area. Ante, total charge by area. Ekkad nunchi, what can you write about charge? Can I simply say Q is equals to sigma into area? Andarki chuskondi. Q is equals to sigma into area. Now I will have to assume the area that covers the electric field lines. Cheppandi, electric field lines are away from the surface kada, perpendicular to surface. Andariki chuskondi. Here also, here also. So what shape will I draw? What shape will I draw? I will draw a cylinder. Again cylinder. Kani, isari, the cylinder will be something like this. Observe cheskondi. This is the cylinder. Are you understanding? So the field lines will go this side also and that side also. Both sides. Both sides. So if, how should I tell you? Okay. So if this is the sheet, this will be the cylinder. Andarki chuskondi. Something like this, kada? Something like this. So here also one cylinder is there. Here also one cylinder is there. I hope it's visible to all of you. So actually one cylinder is there. It is cutting the plate ray. Let us say the radius of the cylinder is R. Andariki. What is the area? Sirji, what is the area, sir? The area is pi r square. Okate area untundi kada? Ledu. ఒక్కటే ఏరియా ఉంటుంది కదా. There are two areas, Sirji. The first area this side and the second area that side. You can't leave any of the area. So total area is pi r square plus pi r square అంటే 2 pi r square. అర్థమైంది అందరికీ? Okay sir, if the total area is 2 pi r square, apply Gauss law. What does Gauss law states? Field line in the right, area in the right. ekkada field line in the left, area in the left. So Gauss law simply states total flux is equals to Q inside by epsilon naught kada. Total flux entira area into field kada. So how many area is there total? 2 pi r square. So you can simply say 2 pi r square is the area into electric field is equals to Q inside by epsilon naught. ఇప్పుడు అదే సేమ్ ప్రాబ్లం రా. వాట్ ఈస్ చార్జ్ ఇన్సైడ్ రే? చార్జ్ ఇస్ ఇన్ఫైనైట్ కదా. కానీ what did I say? Sigma is Q upon area కదా. Q is equals to sigma into area. చెప్పండి. So Q inside is how much ra? Sigma into total area. What is total area re? What is total area? చెప్పు. Total area on the sheet. On the sheet. I'm talking about total area on the sheet. Observe చేసుకోండి. This area only on the sheet. This is charge కదా. ఒకటే side charge ఉంటుంది. So this total area is simply equals to sigma into pi r square. Because there is only one side on this sheet. There are not two sides. On cylinder there are two. But on sheet there is only one side kada. చెప్పండి. So you'll simply write sigma into pi r square. It is the total charge divided by epsilon naught. So ekkadi nunchi you will write again 2 pi r square into E is equals to sigma into pi r square divided by epsilon naught. So this pi cancels, Sirji. R square cancels, Sirji. So 2 into electric field E is equals to sigma by epsilon naught. You divide this to that side. So you will get electric field E is equals to sigma by 2 epsilon naught. Arey gurtu petkondi ra, it is a very important result. So Sirji, na daggara oka infinite sheet unte, let us say sigma is the charge density of this sheet. If the sigma is charge density at a distance very close to this sheet, I can simply say electric field is sigma by 2 epsilon naught. What about the direction, Sirji? What about the direction? Chuskondi ra. Let it be. I'll write here. Chuskondi. What about the direction, Sirji? The direction is radially outwards. Electric field E bar. It is equals to sigma by 2 epsilon naught. ekkada kuda the field is radially outwards, sigma by 2 epsilon naught. Ante kada. At this point also. But you remember it is a very close distance to the sheet, okay? Because it's an infinite sheet. Infinite ante distance which should be very close. It's a sheet, but it should be very close to that sheet. Are you able to visualize? See, this should be the very close. This is sheet and this is the part. Good. Next. Let us talk about electric field in sphere, in hollow sphere. Solid is not there, ra? In hollow sphere. Using Gauss law only, in hollow sphere. Cheppandi andariki. Electric field in hollow sphere andariki. So if it's a hollow sphere, I have three different points, ra? Point number 1, point number 2, point number 2 on the surface only, ra. This is point number 2 and point number 3 outside point, ra. I have to find field at all 3 points. So ela find cheyalante you draw a Gaussian surface, ra. So on point 1 you draw a Gaussian surface like this. So this is my point 1. Similarly on point 2 you draw a Gaussian surface something like this. This is my point 2. And point 3 you draw, I'll take this very close, okay? Because okay, I'll first draw Gaussian surface and then I'll choose the point 3. Okay, so let's say this is point 3, ra. This is point 3. So point 3 you draw a Gaussian surface something like this. So 3 Gaussian surface draw chesina kada. The centers of all the Gaussian surface are in the center of the ring itself, disk, sphere itself. Cheppandi. When I'm talking about sphere 1, it's also sphere, Gaussian surface. Do you think any charge is there inside sphere 1? In sphere 1, no charge is there. Charge ante white color sphere. Chuskondi. This is the charge. This is the charge. This is the charge, okay? This is the charge. Charge is only at this point. So internal point, no charge inside this sphere. No charge. No charge. So what should I write? What should I write? I'll simply say flux is equals to Q inside by epsilon naught kada. Flux is what? Electric field into area 1. Area 1. Let's say the area 1 is A1. R1 kada. This is R1. This is the radius of sphere R. And let's say this is the radius of sphere R2. Area 1 cheppandira. Area of a sphere kada. What is the area of a sphere? Area of a sphere is 4 pi R1 square. So electric field at point 1 into 4 pi R1 square is Q inside 0 kada by epsilon naught. And electric field at point 1 is also 0. Next, let's talk about electric field at point 2 ra. Cheppandi, what should I write? Electric field at point 2 into the area of the second shell. Second Gaussian surface. What is the second Gaussian surface area? 4 pi R square is equals to Q inside. What is inside charge ra? Q only. Q only. Charge is Q only. Okay, I'll write in white color. So the charge is Q only. Cheppandi andariki. So what I'll write is capital Q by epsilon naught kada. So from here I'll simply say E2 is equals to Q divided by 4 pi R square. Send there. So 4 pi R square it went there into epsilon naught kada. Rewrite ra. Rewrite it ra. It will become 4 pi epsilon naught into R square ra. It is 1 into 1 kada. So this 1 by 4 pi epsilon naught becomes K. So this became KQ by R square. So this is my electric field on the surface of the conductor, on the surface of this sphere. At the third point, Sirji, how will I find the field? And this was my sphere. This was my sphere. Radius was R. Kani, I am interested about the third point. Third point ante at this point. So what I'll do, I'll draw again a complete sphere. Chuskondi, are something like this. Adjusted it. Okay. So this is point 3 kada. Cheppandira. If the radius is R2 andariki, chudandi. Tell me. What should I write? Electric field E3 into area of the Gaussian surface. Radius R3 kada, R3. So it is 4 pi R3 whole square is equals to Q inside. What is Q inside? Right? Inside this area, total charge Q is there kada. Chuskondi. Mottam ring is inside this bigger area. So capital Q upon epsilon naught. Ante. So you can simply write E3 is equals to Q by 4 pi R3 square into epsilon naught. Rewrite Q by 4 pi epsilon naught into R3 square kada. Q into 1. This becomes again the value of K. So KQ by R3 square. Ante. So let me just quickly revise the things. Na daggara oka point charge unte or oka sphere is there. So in this sphere, let's say the total charge is Q, radius is R. Electric field at inside point is 0. Electric field on a point on the surface, E is equals to K capital Q by radius of sphere whole square. KQ by R square. Just like a point charge. Baitiki oste, if you're talking about electric field at any external point here, and let's say the distance is simply equals to R3. Okay, so you can simply say the electric field here is KQ by R3 square. Ante kada? Ade. So, Sirji, graph gurunchi matladalante, you chuskondi, just observe it. This is x is equals to 0. This is x is equals to R. And this is any general point, x is greater than R. So, sir, inside point, ante x is starting from 0 to R. Inside point, no field. And immediately after the field line decreases something like this. So this is the graph for electric field E versus distance x for a hollow sphere. Ante kada? Good. Ardhamaindi andariki? Arey, what are you telling? Re. Cheppura. Good. Good, very good. Gauss law completed, okay? So now let's discuss something about ఏం చెప్పాలరా, what to say? Dipole కదా, రైట్, ఎలక్ట్రిక్ డైపోల్ చూసుకోండి. ఎలక్ట్రిక్ డైపోల్ అందరికి ఎలక్ట్రిక్ డైపోల్ ఎలక్ట్రిక్ డైపోల్. సార్ వాట్ ఈస్ డైపోల్? డైపోల్ అంటే డై ప్లస్ పోల్ కదా, డై అంటే 2, పోల్ అంటే 2 poles. సో బేసికలీ ఎలక్ట్రిక్ డైపోల్ లో ఐ విల్ బి హ్యావింగ్ 2 charges separated by some distance. So sir ji, 2 charges ante one charge will be negative q charge and the second charge will be positive q charge. ఈ charges లో separation ఎంత అంటే, let us say this separation is d, but we generally do not say is equal to d only. Okay, we'll take the questions after this. We'll take the questions. Okay, so sir, we'll simply say the distance between the 2 charges equals to 2 times a. Arey, only for the notation purpose ra, only for the notation purpose. Are you understanding? You can say d also, kani d goes a little, off the track. Are you understanding? So you can simply say the distance is 2a. Ippudu we will talk about a vector. What vector ra? Dipole moment vector. Electric dipole moment, it is usually represented by a small letter p and a bar on its head. Electric dipole vector p bar is equals to, cheppandi, you take any one of the charges q multiplied by the distance between the 2 charges 2a. Ante. So q into 2a bar, you can say it is the electric dipole vector. Sir, dipole vector unte direction kuda undali kada. So what is the direction, sir? So the direction of electric dipole, it is always from the negative charge to positive charge. Gurtu pettukondi. So it is always from negative charge to positive charge. So this is the direction of the electric dipole. Eppudu chuskondi, real life lo dipole ki madhyamlo distance ante it should be very small. Okay, 2 charges must be placed very small to make them dipole. Sir, one charge in India, other charge in Pakistan, not there, it will not form dipole at all. Understanding? For a dipole, the charges must be separated by a very small distance. Are you understanding? Good. Then and only then, the whole concept of electric dipole is valid. Arey, I showed it by zooming you, re. Are you understanding? It is a very small thing. Are you understanding? This is the dipole actually. Chuskondi. Is it visible, all of you? I zoomed it up. Arey, zoom chesanu ra nenu. So this is something I am zooming it. See, and then it's visible to you, kada? It is zooming out. But in actually or in real life, the dipole is very small. I hope it's visible to you now. Kada? Good. Very small distance. So sir ji, we have to talk about electric field due to dipole. What all things I have to discuss with you, I am writing over here. Chuskondi. The first thing that I am concerned is dipole moment. I have written over here, kada. And you also have to remember the formulas of all of these. Dipole moment first, gurtu pettukondi. Second one is electric field due to dipole. Second one. The third thing that you have to keep in mind is torque on electric dipole. Ante kada. The fourth field that you have to discuss is energy of dipole. Ante, in external electric field, whatever you want to do. So sir ji, first thing is the dipole moment is represented by p bar. It is q into the distance 2a bar directed from negative charge to positive charge always. Point number 1. Point number 2, I'll write over here. Chuskondi. If this is my negative charge, minus q. If this is my positive charge, plus q. Let us say the distance between the two is 2a, equal to 2a kada. 2a is the distance. What I am doing is I am basically dividing this dipole into 2 parts. So this is the midpoint. So this is the middle line kada. So this distance is a, this distance is a. I will rewrite it. So I can say this is a, this is a kada. Okay, sir. So we will have to find a dipole moment at a general point here. I'll write the points, okay? I'll write the points. Here is the first point. Here is the second point. Here. You extend this axis. This is your second point. Or Leda, this is your second point. Leda, this is your second point. So these 2 points are known as equatorial points. Ardham cheskondi. These 2 points are known as equatorial points. Endukante sir, it is lying on the equator kada. Equatorial point. Ekkada kuda these points are known as equatorial points. And ekkada vachi these points are known as axial points kada. Points on the axis re. Points on the axis. Idi kuda axial point. Ardham undi? Good. Sirji, let us say this distances now. I am going to give you some distances. Let us say this distance is r. This distance is r kada. So now, sir, you can simply say this distance is r1 or you can say this distance is r2. Yedaina you want, you can take it, okay? r1 and r2. So, sirji, electric field on axial point enti ante, you simply say 2k p bar by r2 cube. What is k, sir? K is constant 1 by 4 pi epsilon naught. What is p bar, sir? P bar is dipole moment, ra. Here p bar is equals to dipole moment. What is dipole moment? Q into 2a kada. Ante. So this is the formula for axial electric point, axial electric field points, ra. So it depends, if you are talking about this side, the field line will be directed in this direction. Or if you are talking about this side, the field line will be directed in this direction only. Endukante, చూసుకోండి, this field due to negative charge dominates, distance less kada, distance takwa unte, the field will dominate, negative charge field away, directed towards the charge. Ekkada vaste, this distance is less, so this field will dominate and away from the charge. Axial point ki field lines ardhamaindi. When you are talking about the field lines on a dipole axis, they are always directed from negative charge to positive charge in the same direction as dipole moment p bar. Chuskondi, p bar kada, e bar direction and p bar direction same untundi. So p bar direction enti sir, negative to positive charge. Ante. Are you understanding? Are you able to get it? What are you telling, Ray? Good, good, very good. Chalo. So that means you guys are understanding, right? Chalo. Let's talk about the equatorial points. Now, let's talk about the equatorial points. These are my same dipole ray. It is my negative charge minus q. It is my positive charge plus q, separated by a distance of 2a kada. So I will break these distance into 2 parts. Idi a, this is also a. This is my equatorial point. So sir ji, this distance r unte, you can simply say electric field due to the dipole at the given point. Chuskondi. If you want the directions, first of all, I will tell you about the direction. The direction of electric field at this point due to negative charge towards the charge kada. E point low, electric field due to q bar away from the charge kada. This is the direction. Are you understanding? Andariki? Is it visible to all of you? So the net electric field direction will be something here. It is the direction of E bar. Understanding? And you can simply say the value of E is equals to Kp divided by R cube. For equatorial points, remember, for equatorial points, this is the field at the dipole. Good, very good, very good. ఇప్పుడు జనరల్ పాయింట్ గురించి మాట్లాడతాం రా. సో లెట్స్ సే దిస్ ఈజ్ మై చార్జ్ మైనస్ క్యూ, దిస్ ఈజ్ మై చార్జ్ ప్లస్ క్యూ రా. ఓకే, అండ్ దిస్ ఈజ్ ద డిస్టెన్స్ బిట్వీన్ ద డైపోల్ చార్జెస్. Sarji, let us talk about a general point. Ela maatladutunnaru Sarji. So let us take this is a general point and the distance is r. This distance is r. Andariki cheppandi, is it visible? Yes, good. So Sarji, what is this angle Sarji ante theta? Are you able to understand? Good. So now I can simply say that the electric field at a general point could be given as E is equals to Kp by r cube root of 1 plus 3 cos square theta. Ante. Are you able to understand? Theta is this one. If theta becomes 90 degree ra, cos becomes 0, Kp by r cube 90 ante equatorial point. If theta becomes 0, 1 plus 3 into 1, that becomes 2, 2 Kp by r cube axial point. So sir, IJK system lo ravalante, you can simply say E bar is equals to Kp by r cube into Kp by r cube into 2 cos theta I cap plus sin theta j cap. So this is the electric field at any general point due to the dipole. Dipole moment is always, remember, this is the dipole moment, negative to positive charge. Ardhamaina andariki? Good, good, very good. Ippudu we will talk about the torque. Torque on electric dipole ra. Torque on electric dipole. So by 9 p.m. it will be over, okay? Torque on electric dipole. Cheppandi andariki. So sir, if this is my electric field lines, torque keeps significance only and only if the dipole, ante you assume this is a negative charge, this is a positive charge, okay? Negative, positive. So idi na negative charge and idi na positive charge. So this is my dipole. Sarji, at this instance there is no torque at all. What do? I'll simply rotate this torque. This dipole. So rotate chesi emaitidi ante chuskondi. So if I'm rotating this dipole, what happens is you are getting your dipole in this way. Chuskondi. This is your dipole moment kada. It is a negative charge, it is a positive charge. So dipole moment is in this direction. So let's say this angle is theta ra. Let's say this angle is theta. Observe cheskondi. Electric field E is there. Always remember, okay? Always remember. E ante what ra? E is what? Electric field E is what? Electric field is force experienced by unit charge kada. So you can simply say force is equals to electric field into charge Q. Or you can also say like this. Chuskondi. You can also say electric field E is equals to force per unit charge kada. So from here I can say force is equals to Q into E ra. Kani observe cheskondi. The force on this is in the right side. The force on this is in the left side. Endukante positive charge kada. Positive charge away from the field, it throws himself in the direction of field. Negative charge attracts the field, goes in this direction. Are you understanding? So what happens is the net force right side, left side. Opposite forces, opposite direction, net force is 0. F is equals to 0. But if I have to talk about the torque, remember the value of the torque is equals to P bar cross E bar. P bar ante what? Dipole moment. Are you understanding? So P bar ante 2Q into A bar cross E bar. Ante. So this is the torque on electric dipole. Sarji, what will happen if general different cases are concerned ra? Chuskondi. So this is the torque kada. Case number 1. Case number 1. Case number 1 lo dipole moment or P bar, it is parallel to E bar kada. So this is my electric field. Andarki chuskondi. And dipole also parallel to E bar. Ante the dipole should be something like this. The dipole moment, this is the direction of dipole. Chuskondi. Dipole also in the right side, field also in the right side. So in this case, you can simply say torque is equals to P bar cross E bar. Cross product cheppandi, right, is P into E into sin theta kada. Theta value how much? Theta is equals to 0. So చూడండి, P into E into sin 0, 0 degrees. So it is 0. Torque is 0. So that means if you are keeping the dipole aligned in the direction of electric field, the dipole or the torque is 0. No torque at all. No rotation happens. Sarji, if you are taking the value of theta is equals to 90 degrees. Cheppandi, it is case 2 kada? Case 2. What happens ante, this is the electric field in the right side. And this is my dipole. So let's say this is my dipole moment. This is positive charge, this is negative charge. So dipole moment is in this direction. Cheppandi, what happens is net force is 0. Endukante you try to observe, it is in the right side force and it is in the left side. Force net is 0. What about torque? Tau is equals to P bar cross E bar. Ante P into E into sin theta kada. Theta value 90 degree. You can simply say P into E. This is the value of torque. It will act. Are you understanding? Next, let us talk about energy of dipole. Cheppandi. So if at all this is the electric field, andariki chudandi ikkada. So if this is the electric field if this is the electric field and if this is my dipole this is my dipole moment kada, angle is theta untundi. So in this case the potential energy stored in the dipole kada. Potential energy ante enti, you release it and it will automatically move. You release it, it will automatically move. That means it has a potential energy. So potential energy is equals to simply P bar dot E bar. Ante. You remember the formulas. Ade. Are you able to understand it? Next, we will try to take some questions. We will try to take some questions. The ratio of magnitude of electric field at equatorial and axial. Option A 1:1, option B 2:1, option C 1:2 1:2, and option number D 4:1. Cheppandi andariki. Electric field kada, equatorial position, axial position. So you can simply say E axial is equals to 2kp by r cube. Similarly, E equatorial is equals to kp by r cube. Take the ratio. So E axial by E equatorial, what is cancelled? Kp by r cube, kp by r cube cancel, it is 2 by 1. Reverse, it is asking equatorial to axial kada. So that means E equatorial by E axial is equals to 1 by 2. 1 by 2. Equatorial by axial. Okay. Next. All these are PYQs. I am taking only PYQs. The electric field due to a dipole at a far away point. 19 రా. Option A చూసుకోండి. Option A is 1 upon r. Option B 1 upon r square. Option C 1 upon r cube. And option D 1 upon r cube power 4. చెప్పండి అందరికి. All of you. Tell me. చెప్పండి అందరికి. లో కూడా and also 2023 రా, it has been repeated 2 times. చూసుకోండి, it has been repeated 2 times. అరే what is the formula on axial ray? Electric field on the axial point is equals to 2kp by r cube కదా. అరే చూసుకోండి రా, E is inversely proportional to r cube అంతే. See. Good, very good. Parimala, very good. Ante. That's it. Okay. So it was asked 2 times consecutive. 19 also, 23 also. Very high chance for you also. 26 lo. Chalo. Done with the field lines kada. Next. An electric dipole of dipole moment, an electric dipole of dipole moment P is placed in an external electric field. The torque is dash. It was asked in NEET 2021. Andarki chudandi. Are straightforward formula based questions ra. One is P into E. Option B is P E cos theta. Option C is P E sin theta. And option D is 0. I'll be back in 1 minute, okay, students? Cheppandi andariki. Good, good, very good. See. Arey P is sin theta ra. P is sin theta. It's a very easy question, okay? Very elementary question. Andariki chudandi ra. Chalo. So done with the PYQs of dipole, okay? ఏదైనా డౌట్ ఉంటే చెప్పండి. ఎనీ డౌట్స్? నో డౌట్ కదా? చలో 15. ఓకే, చూద్దాం అమ్మా, చూద్దాం. Yes, there is a question in NEET 2025 also. I am writing on the screen. చూసుకోండి అందరికి. So option C is there, okay? P is sin theta. Next, let's talk about one question, okay? So question is there. An electric dipole with dipole moment ఎంతరా? 5 into 10 to the power minus 6 కదా? చూసుకోండి. I am seeing it on Google. You just verify if it's correct. Coulometer is aligned with uniform electric field of magnitude, uniform magnitude ఎంత? 4 into 10 to the power 5 Newton per Coulomb. అంతే. The dipole is then rotated through angle of 60 degrees. అంతే. ఆప్షన్ నెంబర్ 1 1.0 జూల్. ఇట్ ఈస్ NEET 2025 కదా? చూసుకోండి. 1.8. ఆప్షన్ B is 0.8. ఆప్షన్ C is 1.5 1.2 కదా? 1.5 joule and option D is 1.2 joule. అరే చూసుకోండి రా. What did I write the formula for the energy రా? What did I write the formula for energy? Energy is equals to P bar dot E bar రా. చూసుకోండి. అంటే PE cos theta. అదే. Are you understanding? Initially U1 is equals to aligned kada. So initially situation was something like this. Chuskondi. This was the electric field line and this was the dipole ra. Idi na dipole. Same kada. Aligned with it. Kani final scenario what happened is it has tilted by an angle of 60 degrees. Same electric field lines and idi na dipole. So this is my dipole and idi angle ante 60 degrees kada. Theta is equals to 0. Ikkada theta is equals to 60 degrees. Ante. So U1 is equals to P into E into cos theta 1. Ekkada vachi U2 is equals to P into E into cos theta 2 kada. Ante. So what would you write? Change in potential energy is equals to U1 minus U2 kada. So you can simply say PE into cos of theta 1 minus cos of theta 2. You see, I need magnitude kada. So I am writing U1 minus U2. It should be U2 minus U1, but I know it's more, it's less, so I am writing it. Chuskondi. So P into E into cos theta 1 ante cos 0, 1 minus cos theta 2 ante cos 60 minus half. Chuskondi. 1 minus half. It's positive. So I write it. So here, write the value of P. What is the value of P? 5 into 10 to the power minus 6 into so 5 into 10 to the power minus 6. E value intira. The value of electric field is 4 into 10 to the power 5. 4 into 10 to the power 5 into 1 by 2. Ante. So it is coming out to be 20 into 10 to the power minus 1. 6 minus 5 is minus 1 into half. So it is 10 into 10 to the power minus 1 is equals to 1.0 joules. Ante. So 1.0 joules is the answer. Next, let's talk about electric potential. Okay, it will take half an hour more, okay? In half an hour, this session will be over, andariki. Yes. Half an hour. Yes, very good, Spandana, very good. So, sir ji, let's talk about potential. Electric potential. Ande kada, let us talk about electric potential. What are you typing, re? Andariki. Hey, it will be completed in 15 or 20 minutes. More 15 to 20. Ante. Everything is over. Yes, Spandana, electrostatics nunchi, whatever question have been asked, you tell me, okay? And then we will be seeing it. Are like cheskondira? Are like the video andariki? Okay, so Sarji, what is electric potential ante? You remember, potential is equals to negative integral of E into dx or E bar dot dx. Ante. This is the formula for electric field and potential. Ardhamaindi andariki? Okay. So sir, point number 1, potential is a scalar quantity. Point number 2, cheppandi andariki. Yes, only 15 minutes. At most 15 minutes. Ante kada? Yes. Chalo. So now, Sarji, number 2. Electric field, sir. Electric field due to a charge. What is the formula for electric field due to charge, Sarji? Let's try to find potential due to a point charge. Cheppandi. Did I say potential is equals to negative of integral E dx kada? Cheppandi. Electric field due to a point charge ra. If it is a point charge q at any random distance r, what is the electric field? E is equals to kq by r square kada? Good. You put it here and you try to derive it. So negative of integral of kq by r square dx. Are you understanding? Or dr, cheppandi. Simply you can say dr also. So what is the formula for this? I see, I am not going into much details again. Actually, potential is not defined in this way. So you bring a different charge from infinity to that given point, very slow speed, potential energy, kinetic energy. You just remember this is the formula, okay? So here I am telling you minus kq is a constant, integral of dr upon r squared. So sir ji, it is minus kq divided by, cheppandi, integral dr upon r square is minus 1 upon r. So it comes out to be kq by r. Ante. So this is a potential due to a point charge. Andariki gurtupettukondi. So this is the formula for electric potential ra. Electric potential due to a point charge. So idi na point charge plus q unte at a random distance r, the potential is given by kq by r. Ade if I take the negative q charge, minus q charge, the potential at the same distance r is given by v is equals to minus kq by r. Ardhamaindi andariki. So this is the potential. So sir ji, do we have something known as superposition of the potential? Yes, you have. So if you have multiple charges, చూసుకోండి q1, q2, q3, q4. It is q1, ఇది q2, ఇది నా q3 and this is my q4. Okay sir, due to all these four charges, I have to find the potential at this point VA. So say this distance R1, ఇది distance ante R2, this distance is R3, this distance is R4. Okay, let's do some changes ra. Changes enti ante minus Q3 is there and minus Q1 is there. Cheppandi, what is the net potential? V net is equals to simply V1 plus V2 plus V3 plus V4. Ade. Plus so on and so forth. It is not a vector quantity. You don't add it in a vector form. Not root a square plus b square plus 2ab cos theta. Not valid for it. It's a very simple point. Cheppandi andariki. V1 is how much re? Minus kq1 by r1. Endukante negative charge kada. V2 how much re? Plus kq2 by r2. Cheppandi. V3 how much re? Minus kq3 by r3. Negative charge kada. Plus kq4 by r4. Ante. So this is the net potential. అర్థమైంది అందరికీ. Let us take a question ra. Let's take a question. So let's say నా దగ్గర two charges ఉన్నాయి. The first charge is over here. Let's say q is equals to 2 into 10 to the power minus 4. Let us say second charge is equals to 7 into 10 to the power minus 4. And let us say this distance is 3 meters. Idi also 3 meters. Cheppora potential at point A how much? Question is find potential at point A due to the two masses. Cheppandi. Andariki cheppandi. Can I simply say V net is equals to V1 plus V2 ra? Re చూసుకోండి ra. V1 plus V2. Both are positive charges. చూసుకోండి positive charges. So potential should be positive. K into Q1 divided by R1 plus K into Q2 divided by R2. K value antara 9 into 10 to the power 9 kada. Multiplied by Q1 ki value cheppo. It is nothing but 2 into 10 to the power minus 4. Divided by R1 value antara 3. Plus similarly k into 9 into 10 to the power 9 into q2. What is the value of q2 re? It is 7 into 10 to the power 10 to the power minus 4 divided by r2 is again 3 kada. Good. So sir, I'll do one thing. I'll take this common re. I'll take this common. Cheppo. So it comes out to be 9 into 10 to the power 9 divided by 3 into q1 plus q2 kada. So 2 plus 7 into 10 to the power minus 4. అర్థమైంది. So it is 9 into 10 to the power 9 into 9 into 10 to the power minus 4 by 3. So 3 1s are 3, 3 3s are 9, 9 3s are 27. So 27 into 10 to the power 5. Volt. 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 Unit of the potential is volt. అందరికి చూసుకోండి. అర్థమైనా? So this is the superposition of the potentials. Good. Ippudu, sir, we will talk something about potential due to dipole ra. How is the energy andariki? Okkasari cheppandi naku. Hey, we'll be taking only 15-20 minutes extra. In this 20 minutes, everything will be done, okay? Why spamming re? Yeah. So potential due to dipole ra. Again we have 3 points kada. This is minus q, it is plus q charge ra. Are chudandi observe cheskondi andariki. So idi na dipole moment, negative to positive. Are not right this. I think I should write somewhere here. So this is the dipole moment ra, andariki chuskondi. This is the dipole moment. Kani again I am dividing the whole dipole into 2 parts ra. Chuskondi. The first point is the equatorial point. These are the equatorial points. Again, okay sir, what about these points sir? These are the axial points. Very good sir. And what about a general point sir? Something like this. Chuskondi. So this is a general point. Theta kada. Okay. Sir, this distance is R1. This distance is R2. Observe cheskondi. And this distance is R. General distance is R kada. Good. So, in scenario, if I am talking about points A, points B, and this point C kada, it's point C. So, I can simply say number 1, axial point ra, axial point, chudo ra, axial point and point A and point B kada. So, you can simply say potential at point B is equals to 2kp by r square. Ante. Similarly, if I am talking about equatorial point ra, చూసుకోండి ఈక్విటోరియల్ పాయింట్ అంటే ఏంటిరా పాయింట్ ఏ చూసుకోండి it is a negative side, it's a positive charge, distance is same, so negative positive potential cancel, you are simply adding it, okay, simply adding it. So potential at A is equals to 0. In fact at all points on bisector potential is equals to 0. Lastly, we are talking about a general point. Third scenario. Here I am writing general point ra. General point lo cheppandi. on a general point C, potential at point C is equals to Kp by r square into cos theta. Ante. R3 kada or R, you can simply say R. Ikkada vachi, you can simply say this distance is R2 ra. Ante. So now, let us talk about potential inside a sphere ra. Hollow sphere, okay, hollow sphere. Andariki chudandi. So this is my hollow sphere andariki. This charge is plus q distributed to this sphere. Or should I take some questions? There were some questions asked on the dipole also. Chuddam ra. Question చూసుకోండి. The potential at a point making an angle theta. Dipole option A cos theta by r square, option B sin theta by r cube, option C cos theta by r, and option number D theta by r square. చూసుకోండి అందరికి చెప్పండి. Is there any more question ra? Yes, it is there. Next. చెప్పండి అందరికి చెప్పండి. ఇట్స్ అ వెరీ సింపుల్ ఫార్ములా కదా. జస్ట్ నౌ వి డిరైవ్డ్ రే. అరే వి జస్ట్ నౌ డిరైవ్డ్. చూసుకోండి కేపీ కాస్ థీటా బై ఆర్ స్క్వేర్ డైరెక్ట్లీ ప్రపోర్షనల్ టు కాస్ థీటా బై ఆర్ స్క్వేర్ కదా. అంతే. నెక్స్ట్ వాట్ డిడ్ ఐ సే రే? ఈక్విటోరియల్ పాయింట్ 0 కదా. ఈక్విటోరియల్ పాయింట్ 0 అంతే. నెక్స్ట్ అయిపోయిందిరా. ఓకే, పొటెన్షియల్ డ్యూ టు స్ఫియర్ అందరికీ చూసుకోండి. సో ఇట్స్ క్యాపిటల్ క్యూ చార్జ్. నా దగ్గర అగైన్ 3 పాయింట్స్ ఉంటుంది కదా. గుడ్. So the first point is internal point, point number 1. Second point is on the surface ra. Second point is on the surface re. And the third point is outside point. Andarki chuskondi. So sir ji, what about the internal point sir? The potential at the internal point. Potential at point 1 is equals to how much? Cheppandi andarki. Tell me, all of you. Cheppandi. So sir, this is the center of the sphere. Let us say this distance is r1. ఇది నా distance R2. R2 అంటే radius of sphere కదా, so I'll simply say it is equals to capital R. And let us say the third distance is some general distance రా. So third distance is ఒక general distance, let's say R3 రా. చూసుకోండి, అందరికీ చూసుకోండి. Field inside the conductor is 0. What I'm telling you, field inside the conductor is 0. Field inside the conductor is 0. But what is the formula for potential ra? Potential is integral E into dx kada. So sir ji, from here we can also say electric field is minus dV by dx. Ante. Arey sir, electric field is minus dV by dx. Kani electric field is 0. Ante dV by dx is equals to 0. Where sir? Inside points. Inside points sir, inside points. So dV by dx ante 0, it means change in the potential is equals to 0 ante potential is equals to constant. What does it mean sir? Potential constant ante you can simply say potential on the surface is equals to potential in the internal part. Sir, what is the potential on the surface, sir ji? Potential on the surface is equals to K capital Q upon total radius R, and that is itself the potential in the internal point. Even if R1 is given, potential has nothing to do with R1 ra. Potential internal point lo kuda the same as KQ by capital R, and on the surface also same as KQ by capital R. Ante kada. Now, sir, when you come outside, potential at point 3, it is simply equals to KQ by R3. Ante. So if you want to discuss the graph ra, so graph potential versus x ki 0 nunchi R varaku you are having the same potential. What is the potential? V is equals to KQ by R. Ante. Ippudu R nunchi as the distance is increasing, your potential is going to decrease. So potential is equals to KQ by R. Ade. Are you understanding? This is the graph for potential due to the spheres. Last topic students, last topic is electrostatic potential energy. Andarki chuskondi. Electrostatic potential energy. Sir, if I have two charges close to one another, ఆ సిస్టంలో ఒక పొటెన్షియల్ ఎనర్జీ ఉంటుంది. వాట్ డస్ ఇట్ మీన్ సార్? పొటెన్షియల్ ఎనర్జీ, ఆల్వేస్ రిమెంబర్, పొటెన్షియల్ ఎనర్జీ, ఇట్ మీన్స్ ద ఎనర్జీ దట్ ఈస్ జస్ట్ స్టాపింగ్ ఇట్ టు మూవ్. సో యూ రిలీజ్ ఇట్, దే విల్ మూవ్. That means potential energy. You stretch the rubber, release it, it will move. That means potential energy. You stretch the spring, you release, it will move. You lift, you release, it will move. And it is also potential energy. Are you understanding what I am telling? Good. So, sir ji, now there are two charges, plus Q is there, plus Q1 is there, and sir ji, plus Q2 is there. So, sir, what is the potential energy in the system? Ante, if the two charges are separated by a distance d, so you can simply say d or r, whatever it is there. If the two charges are separated by distance r, you can simply say potential energy is equals to integral of f bar dot dx bar. Ante. Are you understanding? Negative sign, if you want, you can take it also. Cheppandi. So potential energy is system lo, it is equals to k q1 q2 by r. If you have only two system, if you have two charge system ra, if you have two charge system, ante. Sirji, what if I have multiple charges? So I have three different charges. Choose kondi. Idi na charge q1, this is q2, this is q3 ra. Let us say this distance is r1, r2, r3. Andarki cheppandi. So r1, this is r2, this is r3. So sir, net potential energy is, you take the two pairs, match all the pairs that you can take. Sir, I will take q1, q2, good. Sir, I will take q1, q3, good. Sir, I will take q2, q3, good. Only three pairs possible kada. K, q1, q2 you take initially. Take the distance between them. Q1, q2 madhyamlo distance ante r1 kada, plus k q2, q3 divided by the distance between them is r2 ra. Chuskondi. Plus k q1, q3 divided by distance between them is r3 kada. Ante. So this is the potential energy of the system. Now whatever external forces are being added into it, they will only change the energy of the system. Ante. If it's a non-conservative force, this energy will get changed. What if, sir, I have multiple charges systems? So Sarji, I have a square. Chuskondi, andariki chuskondi. So let's say this side is A, this is A, this is A, this is A. Or rather I should say, okay. Now, sir, automatically this becomes the diagonal kada. So the length of the diagonal becomes A root 2. Ekkada gura the length of the diagonal becomes A root 2. Charge Q1 is there, charge Q2 is there, charge Q3 is there, charge Q4 is there. Array, make the pairs. First pair is Q1, Q2. Okay, sir. Next pair is Q2, Q3. Okay, sir. Next pair is Q3, Q4. Okay, sir. Next pair is Q1, Q3. Ardhamaindi, sir. Q2, Q4. Array, what happened? Array, what happened? Array, what happened? I don't know, Ray. What is happening, Ray? Okay, good. Okay, so you make the pairs, Q2, Q4 is there. Ante kada. These are all the forces. Pairs kada. 1, 2, 2, 3, 3, 4, 1, 3, 2, 4. Any other than this? Any more forces or any more pairs I am missing, No, not there, sir. So you take all the forces. So U is equals to K, Q1, Q2 by distance between them, Q1, Q2. Q1, Q2 distance is A. Plus K, Q2, Q3, what is the distance between Q2, Q3? A. Plus K, Q3, Q4, what is the distance between Q3, Q4? Again A. Plus K, Q4. Q1, Q4 is also missing, kada? So Q1, Q4. Okay, so K, Q4, Q1 divided by again the distance is A. Plus, so these are 6, right? Good. Now, K, Q1, Q3 divided by root 2A, andarki chuskondi, plus K, Q2, Q4 divided by root 2 into A. This is my total potential energy of the system. Okay, next. Chuskondi. If there are positive charges, positive term will be there. If there are negative charges, negative term will be there. Andarki. Again, I am telling you, positive charges, positive term. Negative charges, negative term. We will take one more question and we will stop. Chuskondi. Question is, write the question. An electric field E bar is vertically upwards. Full stop. What should be the mass such that it remains at rest? చూసుకోండి అందరికి electric field E bar is there in the vertical direction kada. Good, Sarji, very good. E bar is in vertically upward direction. Mass, I have to find the mass ray. So let's say the mass, or not mass ray. Okay, given it has charge Q. Okay, cheppandi. So it has charge Q, kani I don't know the mass M kada. So how will I find re? Chuskondi. If the electric field is in the upward direction, electric force will be there. How much re? How much force is there? F is equals to Q into E. Remember this formula. E is electric field, F is force in the upward direction. So the force in the upward direction is F is equals to Q into E. What about the downward force, Sarji? What about the downward force? Downward force is mg kada. So if it is an equilibrium, Q into E must be equals to M into G. So from here, M is equals to Q into E divided by G. Ante kada, this should be the mass. Done with the lecture andariki. So I hope it was a fruitful discussion, right? Chalo. Any more doubts you have, or we can stop this session? Andariki cheppandi okkasari. Andariki cheppora. Chalo. Good. Okay, Spandana. Thank you so much. Chalo. Bye. So let's end up this session, re andariki. Yeah. Good night. Have a very good night and very sweet dreams, ra andariki. Okay, sir. We will meet in the. What did I do, re? We will meet tomorrow itself, sir, at 6 p.m. Good. So I think we can stop here.